We get experimental science. We're curious, non-judgmental.
Guys, let us bring on Volcano Doc. Ma'am, thank you so very much for coming on with us today. I know this was a long time planning, but I'm really grateful that you've come and joined us to chat about volcanology and science and just all the things. And also, you are a very inspirational member of the community, and I am stupid excited to just share you with everyone else today.
Thank you. I really appreciate it. I'm sorry, I'm like a bit distracted because I'm like trying to turn this off, this very weird layout. I don't want to see myself. No.
That's the best part, right?
There's like two of me. I'm so very confused right now. Okay, I'm just gonna look at your stream. That's easier.
Right, but then there's the lag on it, and then you're like, wait a minute. what is happening?
Well, I can just hear you.
Okay, and yeah, it's like at least but I know when I've done the guest star before, I'm like trying to look at the person on the stream, but then if I'm listening to the guest star feed, that there's a slight lag, and I'm like, what exactly is going on with your mouth?
No, it's okay.
Okay, awesome. Well, Volcano, thank you so much for coming on. I was hoping, so we've got some samples that we can look under the scope, but I wanted to just chat about too, like your research, the science that you do, kind of your background, and just highlighting you as an amazing scientist and science communicator here on Twitch, and then just like your future goals and how we can best support a fellow science communicator. So I was, just wondering if you can get us started with just a little bit about like who you are and what's your degree in.
Yeah. So thank you so much for having me on. I really appreciate it. And hi, Tommy. And hi, Cordis. I'm just saying hi in chat. So I have a PhD in Earth science. Technically, I'm like looking at the thing. But specifically, I have a PhD in igneous petrology and volcanology. So igneous petrology is a word that means how rocks form. Igneous rocks are rocks that crystallize from magma or lava. So an igneous petrologist is somebody who studies how those igneous rocks form. And then because I apply that igneous petrology to how volcanic eruptions get triggered in specific active systems, that's how I qualify as a volcanologist as well. Because there's all sorts of different types of volcano scientists. Lots of volcano scientists are earthquake scientists, and then there's gas geochemists. There's people who just study like how lava flows move. I'm sorry, I'm going to murder this cat. I told you, in or out. Go. No. We had a discussion. I told her, I looked her right in the eyeball and I was like, right now, you're either in or out. Okay. Next thing I know, I've got one on either side of the door and they're trying to fight underneath, so I'm just done.
I got one sleeping here on the chair, just like in a little fluff ball, and eventually she's gonna get up and decide she needs to go out.
Oh, no, mine aren't cute like that. Mine just murder.
Isn't there some like murder cat counter on the stream as well?
I need to get it fixed. It's yeah.
But anyway, we love them. Sorry. We love them, right?
That is why they are still here. Yeah, Socks has been having some trouble accommodating to our new cat, the Admiral, and so it's been a little bit trying lately.
How old is Socks?
They're both about 4.
Okay.
She is totally fixed. She's just used to being the only cat because I've only had I've had dogs and then her, and so she's not used to being, not the alpha.
Yep.
because she's 9 pounds and pointy, and the admiral is like 16 pounds and pointy.
Wow. Okay. So, yep. Sounds
And
like.
he's a real outside cat.
Uh,
Socks, like, is basically a chihuahua.
it sounds like Noodle with the other cats. She still is not able to hang out with them because she gets too angry.
Mm-hmm.
And then we
I mean, as
actually
long as
we have
as
a
long
socks now
as
too.
she will stay out of my plants, that's fine. But I've I've already lost a couple. Hey Jim, how are you?
A couple of the plants got knocked over.
No, a couple of them died because of her expressing her displeasure in a traditional feline way.
Oh, yep. It's-
I'm trying to just be very very rated G.
yeah, no, I I appreciate you. Just the way you said it. Just typical. Just doing their thing. And yeah, Jim, welcome in. How's it going? Um, so
But
okay, so we were chatting about the different kinds of volcanologists, and it's interesting to me that you said like even an earthquake scientist deals in volcanoes, and is that just because earthquakes can elicit volcanic activity? Is that how that
well,
connection
not all
forms?
earthquake scientists study volcanic earthquakes. There's different types of earthquakes. There's like tectonic earthquakes, and then there's volcanic earthquakes. So, not all seismologists are volcano seismologists.
Gotcha. What is the difference? Like, what is the tecton? Like, what does it mean to be a tectonic earthquake scientist versus one that focuses on the volcano side of things? Like, where is that delineation? And I guess too, like when you say like with the igneous rock formation that connects to volcanology, like how tangible is that connection? Like, is everyone as cool as you that you get to do field work and run into the field around like volcanic sites? And is that kind
Oh,
of what
I
makes it?
do barely any field work compared to most volcanologists. Like, I really do. I don't do very much field work at all. Partially because money, um,
Like from a funding
and
perspective?
partially because I work on active volcanoes. So sometimes field work isn't possible. Sometimes it would require just a lot of coordination. But, like, I'm hoping to go. I have some projects that I'm hoping to start on soon, and one of them I would have the opportunity to do field work, but I wouldn't be required to. And I mean, for this one, like, I would totally go do the field work, but because I do what I specifically do is phase equilibrium modeling of multi-phase, multi-component silicate systems. So in English, that means I do fancy Excel computer calculations for magma things. It sounds a lot cooler than it is. It's just Excel. Um,
No, I think it is extremely cool, regardless if it's Excel or not. Can you break that down for us, Doc? Like, what exactly does that mean? Like, what are you modeling? Like, even like we can show off one of your papers too if you want. Like, just like what does like you as the volcanologist do with it? Like, what kind of data is it that you're collecting? What is it informing you of? What can we use it for?
yeah, so I've got one of my papers right now. I've been working on revisions on stream, which I think is also really important if you've ever wanted to really see what the scientific process is like and like what it's like to actually have to go through peer review. Like when you see like a study from blah blah blah, like that's what this process is. So if you've ever wanted to like understand that, I'll do streams where I'll work on my revisions because I'm very very open with that. And I think that it's important for people to have a window into that. Um, but so for this project, I looked at trying to see if I could use this type of computer modeling to link magma volumes and magma chemistry. Um, I was not able to, and that's because like the models that estimate magma volume are calculated based off of GPS movement. So they actually will like kind of use the changes in land shape and location to figure out where this magma is located and even its shape and how much there is of it.
So what does GPS stand for?
Global positioning system.
Oh,
Sorry.
gotcha. Sorry. Sorry, I was like, wait a minute. I didn't know if
That's
it was
one
like
of those. I'm like, I usually don't have to define that.
No. I thought it was like a volcano word, and I was like, wait, what does that mean? Okay, so like,
No, literally. So one of the ways, like the eruption in Iceland that's going to happen next week, probably. No, they are going in and out, dude. Please and thank you. Sorry, it's my spawn. She's being super helpful. They're just like fighting. They want to come in and out. They're. You know.
Oh yeah.
They're like, oh, very important stream. Yes, we must. Yes. Are there seismologists that focus on off-Earth volcanoes? Yeah, there's even like we've been able to detect Mars quakes. So the Mars lander thing, I don't know the names of them, but whichever one has the latest one that landed, that was drilling into the Earth, it was able to detect Mars quakes. So I mean, it's just like you can. Tectonic earthquakes have a different signature than volcanic earthquakes, and so that's the difference. Tectonic earthquakes are caused by movements of plates. Volcanic earthquakes are caused by magma, like literally breaking through the rock.
And so, is that when you can detect it on Mars? Is that something? Does that mean that you can measure those kinds of events without having an actual seismometer on the surface? Like you can do it from.
No, there is that the lander is the seismometer.
Gotcha. So there's like equipment that has to be on site, and then it can detect if there's changes. So that's why, like, I guess in the movies where there is this guy who comes in and they've got like this seismometer, and they're like, oh my god, there's gonna be a volcanic eruption because look at our instruments. Like you need almost that kind of level of detection, right, with respect to the instruments, like being at physical locations.
You need at the very minimum 3 of those, and that's like you couple that with gas measurements and readouts and pressure differences in pressure measurements, and that's only at a really well monitored volcanic system where you like really know what's going on, like Kilauea, Etna. Many of the system is in Iceland because they behave very similarly. There's very few, like Mount St. Helens, very well understood, very well monitored. And so for volcanoes like that, where you have a well-established record of monitoring, especially when they coincide with eruptions, like that's really what you want, because then you can look at the past history of eruptions and see what the signature of different what do the earthquake signatures look like, that correlate with the volcano doing this, and you have that history to look back on to kind of inform what might be happening in the volcano, because we don't have any way to see inside of a magma chamber. We don't have any way to get in there and detect anything. Like the best we can do is measure areas of the crust below the volcano that are like a little warmer and a little colder, and we know that from differences in seismic velocity speeds. So
and is that meaningful? Is that meaningful data if you don't have it coupled with a past eruption? Like you were like, or is it just like it's just telling you there's heat movement and maybe there's a little bit more warmth here, but that's not necessarily going to indicate that there's an eruption coming if you don't have it coupled with a pre-existing one?
If your volcano is well monitored, which means multiple seismometers, gas thing, the whole kit and caboodle, which most volcanoes are not. Most volcanoes aren't even monitored, let alone
Really?
adequately.
Is that a funding issue?
Yep.
Can I? Why volcano doc? Like not just like not into like why we're not getting money for it, but like why is the sentiment that we don't need to do something like this? Because that, to the naive bystander, and Gigantor is like, oh, how worried should I be about Yellowstone since I live in Colorado? Or like someone who lives near a volcano that's not monitored, how worried should a person be, and should they be calling their state representative to get instrumentation to monitor it? Like, why do you think that is?
I'm sorry, I'm trying to pull up something. So the reason why there's a lack of funding is just general lack of funding in science. Two, it can be difficult on, many volcanoes are sacred land to indigenous peoples, and so you usually do have to, there's, there may be some access issues with the tribes. Sometimes tribes are, very adamantly opposed to installing anything because that is a sacred site and that's their right, that's their religion. And that's where the scientists and indigenous people, indigenous tribes have to work together. And they, the US Geological Survey is in charge of monitoring all the volcanoes in the United States. And I'm going to drop a link into chat here. This is the Volcano Hazards Program. And if you go to their link on monitoring, you can look at like topographic changes, earthquakes. It talks about different seismic signals. You can also go to different volcanoes. So like, let's go to HVO.
It's a really neat tool.
Yeah.
Like, I'm just like there's Alaska has a ton. Like,
Oh,
it's
yeah.
amazing how I did not realize that whole string exists in Alaska. I was
The whole so that's along the Ring of Fire, which is not a thing because they're connected. They're totally not at all connected. It's
okay.
only called the Ring of Fire because there happen to be a bunch of volcanoes around the rim of the Pacific Ocean, and those occur because the oceanic plates are subducting underneath other plates. That's
Aha.
one of the ways that you make a magma. So wherever you have subduction, about 100 kilometers inland, you have volcanoes, which is the case where I live in Cascadia.
Gotcha. So it's, again, each one of these sites like that we have that drop down menu from is like represented here, but not all of them, or most of them don't have like this advanced monitoring that we would want to be able to keep track of how things are moving underground.
Right. And so here I'm going to put in chat here, this is the HVO, and you can see like, you can zoom in here and you can see everything that Kilauea's got. You can look at their instruments. So if you click on instruments on the right, it'll drop it down and you can see the different GPS, infrasound. So we can actually listen to the sounds that volcanoes make.
No way. All right, let's do it.
Way.
All right. So I see station operator. How do we get the sound, Volcano Doc?
Oh no, you can't listen to it. I'm saying like scientists.
We as the researchers.
Yeah, it's infrasound, so like we can't hear it.
Gotcha. I was like, whoa, that's like a live reaction of if there's something happening.
But you can look, like they've got loads of media. So if you scroll down to like multimedia, there's loads of videos of Kilauea and Mauna Loa erupting, and many of them have sound.
Wow.
You can
Okay.
even scroll down and they've got like plots of the earthquake activity and everything. So it's really, really easy. Like using tools like this, it's really easy to keep up with volcanoes near where you live. Now, like I said, not all of them may be monitored. So let me
So,
just.
volcano doc, by not being monitored, do you mean like there just isn't the instrumentation there? Is that so? Can you just walk me through a little bit on these instruments as well for like, and why we would want them? Like, I know that's probably a very naive question to ask, but just like, you know, what is the purpose of each of these pieces of equipment to monitor? Like, why would you want the camera, the GPS? Like, what does this gas thing refer to? What is the infrasound tell us? Like the seismometer, I can follow on, but like the tilt meter, right? Like is there a like what are each of these things, and like what's the benefit of having them, and like in your dream world, if I were to like here is all the money that you will ever want to monitor volcanoes, like which ones would you pick, or would you pick all of them, or is like more the of one versus the other? Like tell me
All of
everything.
them.
All of them. So it's different piece of information, I'm guessing, that give you
Right.
different
Right.
insights, and you take it as the volcanologist, you take everything together, and that gives you the true representation of what's happening.
Yes. Yes. So like with the Iceland eruptions that have been going on, this intrusion, which is what we call it when magma comes up into the earth but doesn't erupt, right? So if you have magma coming up from below and it doesn't erupt, we just call it an intrusion.
Mm-hmm.
Not all, like most of the time, actually, these things don't erupt. There's a lot of magma that doesn't erupt compared to the, percents that do in like places like Iceland and Hawaii. Um,
Is why
but
do we know what the difference is between an intrusion event versus actual volcanic eruption?
it
Like
just has to reach the surface.
okay, so it's not that something about the ground is fundamentally different and it will prevent a volcanic eruption. It just didn't go high enough.
Mm-hmm.
Okay, that's really interesting. So it always has the potential to erupt or to intrude, and it just depends on these other signals if of what's going to happen.
Yeah, so like if I have a magma, like let's say the way that you make a magma is by taking the Earth's mantle, which is a solid,
Mm-hmm.
and melting it. And so that residual liquid is called a melt. That melt is liquid hot, which is probably going to be around 1200 degrees C,
Wow.
about 2400 Fahrenheit,
Okay.
roughly. I'm bad at that conversion. I really just only know centigrade. It's Celsius.
Exactly. Say like in a lab setting, Celsius was I get. In the real world, it's Fahrenheit, and I can't switch between them.
Yeah, I'm incapable of switching between the two. Like, totally.
And you'd
So
think we
I
would,
feel
because we
you.
use both all the time, and it should be so easy.
Oh. It's incredibly hot. It's incredibly hot.
and
Hey,
and
Skip, how are you?
and just so we're
Um,
clear, that liquid state is not magma, right?
it that at that point it is. It
It is.
is.
So is magma liquid hot?
Initially.
Okay.
And at that point we call that temperature the liquidus temperature.
Just because of describing the state of it.
That's the
Gotcha.
state of the system. It's the liquidus temperature. That is the temperature at which the very first crystal will form. So if you take that magma away from its heat source, as a magma like moves away from the mantle up through Earth's crust, the crust is like taking heat away from it,
Mm-hmm.
and then it will start to cool, and as it starts to cool, it crystallizes. Usually, what happens is that those crystals, as the magma's traveling upwards, those crystals will settle out, and this is a process called fractional crystallization. When those crystals settle out, it's like kind of like removing if you have a bowl of Skittles, it's like taking all the blue Skittles out. You still
Okay.
have a bowl of Skittles, but the proportions of colors have changed, right?
Yep.
And then so maybe the next mineral are orange Skittles. And now all the orange Skittles come out, right? And then the proportion of different colors in your bowl, the chemistry of the remaining liquid has changed, right?
So is the way this ties back to that paper you're publishing was using the position of the magma to predict chemical structure, right? Because yeah, you're saying it's if it's shifting upward, going through the soil, it's changing temperature and potentially the chemical composition too, right? Am I
Right.
so that it would be a way to predict like maybe how far along you are to the potentially a volcanic eruption. Is that
Think it's safe now, Father.
Well, this is this is more of like how far along the chemical evolution of a magma, like the typical way that a magma will change its chemistry. Like there are a couple known ways, like and it's more of like how far along that. It's nothing to do with the volcano.
gotcha? It's like it's independent of where. So like I guess okay. So I'm so sorry, Volcano. Can you define us? What is a volcano? Like classically.
A volcano is any opening in the ground that lava comes out of. It does
Okay.
not have to be a cone. It doesn't have to be a hill. It can just be a crack, and that's called a fissure. Usually, fissures are long linear cracks, and that's where you get these nice fire fountains that come out of. Those are fairly effusive eruptions. I actually have a bit of one. This is called a bomb. This is from Hawaii. And so this is a bit of lava. You can see how it's like football shaped, right?
Yeah.
So it's football shaped because it's cooled as it's traveled through the air, right? It quenches on this
Oh,
crust.
so that was launched out of
This
the
was
mantle.
launched out of the volcano,
Uh-huh.
and it goes up parabolically. And you can use the like what is it, like 1/2 ht squared equation to calculate the height. We had a viewer in my chat did that with the Iceland fissure, and he was within 5 meters. It was great.
Wow.
Yeah. But what's really cool about this is on this side, so here's the lava, right? This is called a xenolith. This is a mantle xenolith. This is a chunk of Earth's mantle that didn't melt, that got brought up with the liquid part of the magma.
Wow.
And so these are ways that we know what the inside of the Earth is like.
Wow.
Without these mantle xenoliths, we have no way of like getting bits of the inside of the Earth.
Do we know how deep from within the earth something like that is from?
Give me 1 second. I'm really bad with my depths.
No. This is me being y'all just to be
Anywhere from 100 kilometers to 2,890 kilometers.
okay. So it's a range that you identify, and it's not like there's a telltale sign of which one of those extremes it's at. It's just like from within that range is what you're getting out.
Yeah, and you can actually tell there's a one of the community members in my chat, Deep Earthbound. They're an isotope geochemist, and they literally, this is what they do: is they study the mantle rocks to figure out what Earth's mantle is like, and even Earth's core. So different minerals will crystallize at different pressures and temperatures,
Mm-hmm.
and using those mineral assemblages and then the chemistry of those minerals and different techniques, you can figure out how deep in the Earth's mantle this came from.
Wow. Okay, so it's not just like a mystery ball of dirt almost like that's on the lava. It's like there are ways to really narrow down within that range of where it is, and that's incredible. That's where we get like the snapshot of what's within the earth.
Mm-hmm.
And when you found that piece of lava, or I guess what is it called now that it's solidified?
So this is a bomb. This is lava.
Okay.
Yeah. If it magma and lava chemically same thing.
Uh-huh.
The only difference is that Lava comes out of the volcano. That's it.
So when it's underground, it's magma.
Mm-hmm.
If it's
When
shot
well,
out,
before it erupts, it's magma.
uh-huh.
The reason I say that is because you can have lava tubes that travel just underneath the ground,
Mm-hmm.
like, or lava tubes that form, and then the lava's going, like, if the lava travels through an underground cave or something, it's still erupted out because it's still come out of the system, so it's still
Gotcha.
lava.
So if there's like an aquifer underground or something, like a natural water source, and like magma leaks into that.
Oh, it's in a big explosion. That's called a mar, and that's what Docero Crater is. That's also what the Clear Lake Volcanic Field is, which is the geothermal field north of San Francisco.
Why does that explode?
Because water and magma essentially, it is the same physics as molten fuel coolant interaction.
That's so cool. I'm so sorry, Volcano Dog. I'm like, oh, surely it's like just a gentle breeze into it. And no, that's really fascinating. So when you're doing like these surveys, I imagine that you have to be aware, like within a volcanic area, like then what are the aquifers? Like what's the underground system that the lava, or I guess the magma, can go into to potentially become lava instead of just a regular old eruption, like classically out of the ground.
That is not something I ever deal with. Um, if I mean, you would have to have like a pretty big aquifer for the mar to occur. Um, Depending on like the volume, sometimes the heat from the magma will just boil it off.
Gotcha.
Um, so, but there's all sorts of, like, there's so many variables.
No, I think, but that's the really cool part, right? Is that there are so many variables, and right, I think it goes easily underappreciated that what you do isn't just like, oh, here there might be a volcano here, like let's like look at a few readings and that's that. No, it's like you're dealing with an absurd number of variables.
Oh yeah, like even like the models I do are just, and they're really complex and they take into account so many variables and they're still like stupid unrealistic.
Is
Like a
that because it's
model.
like still simple relative to what could happen? So I guess similar to
Mm-hmm.
like our genetic models, where it's you're trying to do with like an enzyme interacting with a protein, and you've got a little web, but in reality, if you were to drop that into an actual organism, the web is like quintupled or something, and it's like far more feeding into one another than just those like 10 things that you've pulled out.
Yeah, like if what was I gonna say? Oh shoot. I was gonna say something just now and I like had it in my brain. Oh my goodness, I'm so sorry.
That was me.
We were talking about water. Oh yeah. Okay, so you know what the Leidenfrost effect is, right?
Tell us, Volcano Doc.
The Leidenfrost effect is like when you have water and something hot interact, and then you have that like little level of steam, that
Mm-hmm.
like little layer of steam that builds up in between them. I like think about it like a air hockey table.
Okay, it's like
How
floating. The two things are held in place
Yeah,
by this pressurized air.
right, exactly. So a Leidenfrost layer is when that steam layer develops. So if magma and water, actually, I'm gonna try to find this YouTube video because I really want you guys to see it.
Apologies,
Um,
Volcano Doc, that we are just rabbit holing all over the place, but there's just I have so many questions for you, and it's just so cool to illustrate like how complex all of these different factors actually are. It's never as simple as what we imagine it to be.
oh yeah. So check this out. I just dropped this into chat. This is the West Mata eruption. This is an under underwater eruption. This is like the first time that this kind of footage was captured, and it was 2009. But still, like, this is a young science. So in this case, this is still like, it says explosive. No, no, no. This is no. This is a very passive eruption, and this is what most volcanoes in the world that are underwater would do, where the magma comes up relatively slowly. So if it comes up slowly, then it has enough time for that. You have enough time for that Leidenfrost layer to develop. But if the magma comes into contact very quickly with the water, and you don't develop that Leidenfrost layer, that's when you get the molten fuel coolant interaction.
Gotcha. So, like you saying, this is the more typical that we have. This
Yeah,
very slow
this is
moving.
very 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 common, like passive. So like all along the Mid Atlantic Ridge, that like where the Earth's crust is spreading apart, those underwater oceanic ridges, the volcanoes, like when you and Lita looked at the black smokers, these are those types of eruptions. The volcanic eruptions that would be nearby, this is what it is. Hey, Planetary, how are you?
And welcome in. Moonrise says, I remember heading into Volcano Cowboys about how Mount St. Helens changed volcanology because it was the first violent eruption within a time of technology capable of capturing it essentially in real time.
100% Moonrise. 100%. Like, we owe so much of what we know to Mount St. Helens, especially the months leading up to the eruption, and following too. Excuse me. Because after, for those of you who don't know, after the very very explosive uh lateral blast that Mount St. Helens is widely known for, the eruption continued. There was a Plinian. Was it Plinian? Yeah, I think it was Plinian. Maybe it was Vulcanian. But there was a pretty steady eruption plume for like 9 hours, like sustained volcanism for 9 hours, which is not small. That's pretty impressive. And then I think it was a few weeks later, maybe, or a few months. Um, it started erupting again, but because most of the gas had been like come out with the initial eruption, you had a lava dome kind of like squeeze up. So if you like squeeze a tube of toothpaste and it comes up like whoop, then that's like essentially a lava dome. And that's what it did from 1980 to 1986, and again from 2004 to 2008. And so we have modern readings with a well monitored system for that entire time. And like it's so we know so much about uh the like more infrequent eruptions, like the I don't want to call them like arc volcanoes, like the Cascade arc volcanoes, things like the Andes, the Alaskan arc volcanoes. We know a lot about how these eruptions behave from Mount St. Helens. For Kilauea is the natural laboratory for many volcanoes. The Hawaiian Volcano Observatory was established in 1912, and yeah, with those two, and then Etna. There's a few others around the world as well, but based on years and decades of readings from these different volcanoes, we kind of know what to expect when other volcanoes give these signals out. So for ones that we don't have a good history of, because they erupt very infrequently, I did hybrid. I did. And then Mama Izafan, I'm going to get back to your question after this, because I am actually an expert on Lassen. I did my master's and part of my PhD on that. I've written a guidebook entry for a Lassen field trip, and I'm working with one of my friends is doing his like kind of master's project-ish on the Brokoff, like pre-Lassen stage extra explosive volcanism. So
Nice.
yes. Yeah. I got tangent. I'm sorry.
No. Please, this is like, I think that's the beauty of this, right? First of all, it's a live stream, so we can go on tangents, right, with from Chad. But also, I think that kind of ties back to what you were saying at the beginning, where we need the equipment on the sites. So you can get these readings, and like we've learned from these active eruptions where you did have equipment on site. And I could imagine that if we had more equipment on site with additional volcanic activity, you could learn more and get better at predicting when things are going to happen.
Yes. That's the dream. That's the hope.
Nice. And then I will ask you about these items of like what's to have, like in terms of detection, but I don't know if you wanted to get
so I'll answer Mama Isafan's questions, and then yes, we'll go over what those things detect. So Lassen is still active, and I'm really glad that you asked it that way, Mama Isafan. This is something that most people don't really understand. An active volcano is any volcano that has erupted within the last 10,000 years, or we know from monitoring that there is an active volcanic system there. So like Yellowstone, hasn't erupted within the last 10,000 years, but we've got an active system there. So that is considered active.
What is an active system, Volcano Doc?
There's heat, earthquakes.
Gotcha. So
fumaroles,
it's like
geysers.
Even though there hasn't been that volcanic explosion, when you put the sensors in, you're getting activity based on what we have from like previous actual explosions. So you're predicting that it's a site where something might happen.
Yeah, you see like readings that are consistent with the presence of a magma chamber.
Gotcha. Cool.
So readings that are consistent with the presence of an active magma chamber. Sorry.
Nice. And that's what means if something's active. 10,000 years or your quote active readings.
Yeah.
Nice.
Correct. And so we don't really use the term dormant because that's very misleading. Instead, it's active or actively erupting. If stuff's coming out, it's actively erupting. There's ongoing eruptive activity. But so who was it? Hybrid Robotics. I live in Vancouver now, like North Portland, Vancouver, and it's incredible how many people here. So if you are not familiar with the Portland metro area, I can see Mount Hood, which is an active volcano, Mount St. Helens, which is an active volcano, and Mount Adams, which is an active volcano, on a clear day. Like 3 active Cascade volcanoes around this very big metro area. And people only think about Mount St. Helens. They don't realize that Mount Hood is very active. When Lewis and Clark came through in 1790, they named the Sandy River because it was full of lahar deposit.
Oh wow.
That had just erupted. Like Hood is still very, very active.
So why
you can hike up to its vent?
Like why is there almost this disconnect where it's only St. Helen that's thought about versus not the other two?
Because, and I think this is something that is easily seen when you think about how people responded to COVID. People don't fear what they don't see. If you don't have an eruption, like there has not been an eruption within our lifetime for Mount Hood or Mount Adams, or Mount Rainier, or Baker or Glacier Peak, or Three Sisters, or Newberry, or Crater Lake, or Medicine Lake, or Mount Shasta, or Lassen.
Oh wow! So there's yeah.
And that's just in the Cascade Range.
Wow! But all of them could because they're. I guess they'd
but
be
all
classified.
Of them are active.
They'd be active classified, right? Like we just said.
Yeah. And so I think that there's the disconnect because since there hasn't been an eruption, they just don't. There's just I don't know.
Umo Poppies, DN Pow, welcome the heck in, Raiders. Uno Raid, how was your stream, Umo? Tell us all the things. Little to the left. Is that a game or a way of life? Umo, welcome the heck in. We're on today with a very special guest, Volcano Doc, professor of volcanology extraordinaire, and we're talking about volcano science. Usually we do microscopy Mondays today, and we do have samples to look at as well. So if y'all have any questions about volcanoes, magma, should we be nervous? All the things. Come on in and ask Volcano Doc. Raiders, welcome in. My name is Balens, 1/3 of SciAnts Streams. Other 2/3 are my lovely wife Lita and our daughter baby Alona. Lita and I are biologists. We're research scientists doing Twitch interactive streams 7 days a week. And again, I'm very pleased to have on one of our besties, the lovely Volcano Doc, who I got to meet at TwitchCon, and she is in fact even more amazing in person than she is on stream.
You're really, really sweet, dude. I appreciate it.
I only speak the truth. I only speak the truth.
Well, thanks. Yellowstone is very well monitored, by the way.
Nice.
Coffee rocks.
Good. So let's see. Umo says it's a cool little organization game similar to the game Unpacking. Nice. Well, Umo, if there's anything you'd like to share, feel free to drop it in the chat. And guys, go check out our friend Umo. I see Tippets69 coming in as well. Double Dot, welcome on in, everybody. Please come on in if y'all want to learn some science, considering the follow button. But also in the episode description today, there is a hot link, 2 hot links to Volcano Doc's name, in fact. Click on those hot links and blow up her follow alerts. I want her computer to crash with so many follows coming in. That is my dream for today, y'all, because while she might not openly ever say it, she deserves Twitch partner faster than my head can spin. Because she is an amazing scientist and science communicator. I want her nothing to be but like the big check mark by her name. I will manifest it, chat. But welcome on in, y'all. Double Dot asks, is magma lava always the same, or are there different ones? Oh, we can't hear you, Volcano Doc.
Oh, no, I just muted myself. I'm sorry. There are many different kinds. Sorry.
Many different kinds. And stick around, Double Dot, to get some of those answers. So we're talking about Mount St. Helens and the eruptions. It could be involved in, like, which volcanoes should we be nervous about erupting? What is the definition of an active volcano, which is anything that's apparently erupted in the past 10,000 years, or is showing signs of activity, which... And you said something really that I was connected to, Volcano Doc, is that dormant is not something that we commonly use anymore. And
right. I really try to tell people this because, like I said, I have 3 active volcanoes right here, and people only think about the one because Mount St. Helens erupted. And they don't think that Mount Adams or Mount Hood are active, and they both are very, very active. Now, will they have explosive eruptions like Mount St. Helens? I can't say no, but I can say, lean towards the more likely not, because, and this is one of the reasons why it's very important to look at past eruptions, because volcanologists like me use past eruptions. I can go out and I sample the rocks from past eruptions, and then I use those to figure out what caused those eruptions. Because then we know, okay, well, that's how this volcano has behaved in the past, over the past 8, 10, 20 eruptions. So the next time it erupts, this is likely what can happen. And that can be anything from, oh, this really only has lava flows. We really don't see big massive eruptions here. Versus, oh yeah, we get little, small cone building eruptions. But every 1,000 years we have a giant caldera forming eruption and everything gets blown out of the way, and that is the case in one volcano that I study, so it's just like dormant is very inaccurate because it gives this illusion that something needs to wake up. Mm-hmm. And although there are volcanoes that do need, like, their magma system does kind of need to be heated back up, because they're stored too mushy, too viscous to erupt. We don't know how to read those signals yet, so we can't say when something, dormant, well, we can't say when something might be waking up. It's just better to say, like, hey, it's active, like, there's potential there. Or yeah, it's been so long that it would just be very, very, very highly improbable for this to go again.
So would you say it's never actually quite dormant in terms of what we're
Yeah.
calling it? Because like I just think back when I was a kid, the way that was illustrated in the books, like I had children's books on this thing, is like the active one has like internal, the magma pictures and drawings, and the dormant it's like this cold stone looking for like a lump almost, right? Where it's not
That's how
actually.
magmas exist most of the time.
Mhm.
Magmas usually, and especially in these arc volcanoes, like not Kilauea, but like Mount St. Helens, Yellowstone, uh, Cotopaxi, Hood, Lassen, pretty much anything sitting in thick crust usually exists as a mush. And if a magma is more than 50% crystalline, it is too viscous to erupt.
Okay.
So then you need to have more magma that is hotter, more liquid come in, kind of mix with it and remobilize it, remelt it, and get it so that it's less than 50% crystalline and therefore eruptible. And then you have an eruptible potential. Um, and like it's just the there's all sorts of different variables that even control, like, yeah, there's just so many variables. We just say active.
But that was kind of the point of that the paper you were putting together too, is just like I can imagine the use of that, right? Of like if you can detect like where it is in the chemical composition and like how far along therefore it is in terms of like likelihood of erupting. If it's like the chemical composition is in this 50% zone, you're like, all right, we're not exactly at an impasse yet where we need to be alarmed because it's just not hot enough, and here's how it would counter that. So it's like it's really cool about how you can link those together. I realize there's a lot more variables coming in, but like
Well, so I'm gonna stop you right there because it's not quite right, and I don't want to. I want to make sure that I clear the air, and so I apologize if I gave you that impression. What I've done with my Kilauea study is I used the volumes that were calculated for this intrusion that happened in 1997. So I'm working off of old lavas. I'm not working on something that is about to erupt.
gotcha.
I just wanted to clear that up.
But it could be like if you have the model working out on the past ones, the idea is if it works there, then maybe we can apply it to ones that are active, right?
Yeah, so like there's I'm going to be very, very cagey about this because you never know who's out there. Um, so let's say, for example, if there was an eruption and part of like one side of the volcano eruption part was one chemistry and the other side was another chemistry and like maybe some crystals. The thing is that you can have, when you have different chemistries, the higher silica stuff tends to be a little bit more explosive. And so what I did during my Kilauea, using my MCS for my Kilauea project, was I used the mineral compositions in the lava to estimate the chemistry of this like shallow magma that was like hidden in the crust, how much it had evolved, and how solid it was immediately before the mixing event and then at the time of eruption. And so, with this other volcano that could possibly have these conditions that I was just talking about, perhaps that could be used for, all right, well, we've got shallow hidden magma bodies, which is something that within the last 8 years, 10 years, we're just now kind of realizing pose a very real threat in places we didn't really think about.
Oh wow. Okay.
Yeah. So what are we dealing with here? We've got one big fissure, but we've got two different lava types below the surface that are mixing with, or maybe just one, and then this isn't mixing. What's going on? Because if that volcano continues to erupt, as I imagine it will, then, if the one side of the fissure that has the potentially more explosive magma could erupt, then you need to be prepared for that potential hazard. Does that make sense?
That's really, I mean, it's scary, but it also is really cool that there's this element of the double types of magma. Like, I don't know, naively just assume that it's just a single type flowing through at least in a given chamber. Like, I rationally, you get, like, in a different area, it might be different, but it's really cool to think about within the same area.
Well, like I said, we didn't know about this until 2018.
Well, I don't, obviously, I'm not trying to quiz you, Volcano. I'm just genuinely curious, so please, if at any point you're like, Blunt, you gotta cool these questions, you just tell me.
You're fine.
But, like, how did we find it out? Like, what was the kicker in 2018 where someone was like...
Because when Kilauea erupted in 2018, down at the end of the Lower East Drift Zone, so if you want to zoom in, up. Lower East Drift Zone, yep, down on the point. Yeah. So if you go to the caldera, this is the central Kilauea summit caldera. And then there are two rift zones. There's a rift zone down the southwest and then a rift zone out the east. So we're going to go all the way down the east rift zone.
Is that... Volcano, I don't even know what a rift zone looks like.
Just follow the chain of the volcanoes.
Oh, like here?
Yeah, where it's brown. Down.
Uh-huh.
Yeah.
Oh, these.
Yeah, those
Okay.
are fresh. That's fresh lava. That's the east rift zone.
Okay.
Mhm.
And then it just is going down this way?
That's just the lava flow. You can continue on and you see all those chains of craters. All those are, like, that right there, that's the Pu'u'o field. That was, like, erupting for 36 years.
Oh. That's
Yeah.
so cool.
So in order for something to be a new eruption, there has to be a break of 90 days or more. So 3-month or greater pause. So at no point between January 3rd, 1983 or like April 14th, 2018 was there a break of 90 days or more.
Wow. So it's a continuous years of eruption.
Yasser volcano in Vanuatu in the South Pacific has been erupting continuously since the late 1700s.
Why?
At least.
What? I don't know if that question even makes sense, but like, what? Why doesn't this like get done?
How these long-lived, sustained things, like we're still, yeah. So I've missed so many questions in chat. I'm sorry. Yes, it's a hotspot, but yeah, we don't really understand how long-lived lava lakes form, really.
That's mind-boggling. Can you for over 300 years? It's just constantly.
Yeah, we are totally. But the Earth is 4.56 billion years old, right? That rock that you've got that we're gonna look at later, that rock is 1.7 billion years old. Like, how old are we? We don't matter in the Earth's. Like, I think that's one of the things that I love about earth science is that, like, we're so in, like, not even, with the exception of climate change, because that's pretty gnarly. And that is the one way that we have definitely messed up. But in terms of volcanoes and geologic time scales, humans are insignificant.
So in that sense, like, it going for 300 years constantly is probably nothing compared to how long it could go or has gone. Like, I guess like you're saying, and that's a really good way of putting it in context.
Where's my drink? What drink?
Thank you, Dan. Where we have, some things that's flowing, like, has a big explosion. Like, we just, I don't know, like... Tommy!
Don't tell me you forgot
we think it's like the one-off, right? The one-off that happens and like the big explosion and the 300-year cycle is the weird thing, but really we're the weird one. Yeah, for the time scale that we're looking at.
That's why I'm always late. That's why my streams are never like you. I can't get a schedule because I run on geologic time.
But if people were to look for you, when would they find? We're gonna do a shameless plug of Volcano Dog right now.
Sundays, and then I've got the schedule on in as much as I can because I've got a couple collabs coming up. One with Fred Hutch, and then one with Belint, and then I think we're gonna have a herpetologist on, and uh, maybe somebody who studies the Earth's core. Not sure.
Perfect.
And those will be on Saturday mornings. But yeah,
Nice.
mostly on Sundays.
36 seconds, Volcano Dog, before we give you another fancy pants shout out. Guys, please, 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 we go following Volcano Dog. Professor of Volcanology, science communicator extraordinaire, was with us on the TwitchCon panel. She is brilliant, and we are just scratching the surface of like.
I'm going up to chat because there were so many questions that I missed. What makes Farfamatic? What makes Devil's Tower such a strange anomaly? It's a plug, so it's not dormant. It's totally extinct. It's a plug. It's like all of the lava that was in the conduit cooled, and then the outside of the volcano eroded, and then just the stuff that was in the conduit is left. That's what Devil's Tower is. Like that, and that's pretty common. That's pretty common.
What does it mean, Volcano Dog?
I would not be concerned, really, hybrid. Like with the Cascade volcanoes, they give warning. You know, we saw that with Mount St. Helens. They give considerable warning. This is not like, it's not as in a you wouldn't know. You'd know. You and like the USGS, they have people's safety as their number one big concern. So like they absolutely would tell you like public safety is the whole reason that they have the volcano disaster hazard program. Like the VDAP is the volcano disaster assistance program, and they have volcano hazards program. Like that's what they care about. And as a community, we would let you know, like 100%. There's no ifs, ands, or buts. Oh, you live in San Diego, so it's the Salton Sea is what you have to worry about, because at the south end of the Salton Sea, there's an active volcano there. That one we really don't know very much about. So,
is the lack of knowing due to just no instrumentation on the site and monitoring?
You know, I'm not sure. Let's see.
And again, we do have the site, right? Which is like lets you go and look, which is really cool.
That's what I'm doing right now. It's called Salton Buttes. And it is, yep, it's kind of underwater. The cone of it pokes out, so there's like a little island at the southeast end of the Salton Sea, and that is Salton Buttes. It last erupted about 2,000 years ago. No south, and nothing on the East Coast, nothing in the Midwest is active. All of that is, there's the tectonic setting does not exist to have active volcanism over there. Thank you so much for the follow, South Rebel.
Yes, everyone, y'all, please blow up her follows. My goal is to crash the stream with having too many follows. And by too many, I don't mean there's enough.
Let's see. Are we... Blah, blah, blah. Oh my gosh, I'm so behind. I'm so behind. Dante's Peak is it's slightly cringy, but it's the most accurate volcano movie that exists so far.
Is it bad that I've never seen it?
No.
Okay. Is it like a must-watch for fans of volcanoes? No. Okay.
I mean, it's worth watching. It's the most accurate disaster volcano movie, in terms of like hazards and how they present and things like that. I don't really care for disaster movies. They just tick me off. So I just don't watch them. Yeah.
Oh, Planetary Pan. I've seen San Andreas. Anything with The Rock, I'll watch. I love like, no.
Moonrise, I would love Hecla Tephra. That would be amazing, especially if you have a GPS coordinate. I would love that. That would be fantastic. Pyroclastic surges are, oh yeah, pyroclastic surges are crazy. Pyroclastic surges are when, like, basically the lateral blast from Mount St. Helens, kind of, except for not going sideways. It comes rolling down the mountain. They are incredibly, incredibly dangerous. There's basically no way to get to survive them. Yeah. Hey, Deep Earth. Sorry, I'm like catching up. Okay, I think I'm. There's no way I can catch up. I don't know what to do.
Y'all, if we
Okay,
have missed
pull
a
in.
question, please
Okay.
post it again in chat. Don't worry, y'all. How long do we have you for tonight, Volcano Doc?
A couple more hours, probably.
Okay. Let us know at
Wow.
any point where it's like, all right, like here's 10 minutes. I need to get
I'll just
going.
need to get us. I'll just need to snack. I'll just need to snack.
Okay, I just want
budgeted my
to
evening
be
out.
respectful of your time, and just we're very grateful that Volcano Doc is here with us answering our questions. And I was monopolizing, y'all. I'll admit I was just kept asking questions and questions.
Oh, that's okay.
Moo was wondering.
DC, are we seeing an increase in lightning strikes from ash in more recent eruptions? There's no increase in like lightning strikes for. I mean, there's no increase. Like there's no correlation with years on Earth and the amount of lightning in an eruption. Lightning forms in eruption plumes because of the friction between particles, and there are a lot of different reasons and ways that lightning can form, and it depends on a lot of different things in the plume. But I mean, everything is particular to the circumstances of that single eruption. There's no like correlation across time or between volcanoes. Everything is really like, basically you have to look at each volcano as its own system, and sometimes even individual eruptions as kind of like their own behavior. Sometimes they can just be out of the ordinary, but usually you look at like a single volcano as its own system, and then based on how individual systems behave, then you can make broad generalizations about types of volcanoes, like how Hawaii doesn't have explosive volcanism. I mean, Hawaii had a very explosive caldera forming eruption. The Kilauea caldera collapsed, I think, in like 1790 or something, or like 1720. But there's, several hundred indigenous Hawaiians died in that caldera forming eruption. It was very, very explosive, and ash has covered the entire island from it. But that's very, very rare.
Volcano Doc, when you say caldera forming, what does that entail?
Caldera forming is essentially where, like, think of it as the magma chamber is pretty much emptied out and there's nothing left to support the top, and so it collapses in on itself.
So is that when you see that classic, like, almost crater that's formed? Is that what's that stemming from? Is that there's been an in-collapse, or does that happen independent?
In the top of a cone?
Yeah.
No, that's just a crater.
Gotcha.
That's just a crater.
Okay. Fundamentally
Yellowstone is a good example of a caldera.
Okay.
Because it's like, if you look at Yellowstone from the side, you don't see a giant volcano. Right? You just, like, the explosive eruptions of Yellowstone are caldera forming eruptions. It will literally just be and just leave a giant hole in the ground.
And everything gets emptied from that one reaction.
Yeah, for a big caldera forming eruption, yes. So like the Tonga eruption in January 2022, that was a caldera forming eruption.
Wow. So then, would you ever get a caldera forming one from one of those long flowing times? Like the one that's been going for 300 years, if it eventually empties, is that also a caldera, or is it linked in a way to that explosive boom?
I don't know that system well enough to say.
Gotcha.
I can tell you, like with Kilauea's had a caldera forming eruption, that one in like the 1790, I think.
Mm-hmm.
But most of the time, it's a very effusive, passive, non-explosive eruption. I don't know enough about Yasser to say.
Yeah, of course. No, and y'all, again, the sign of a brilliant scientist. She's like, yeah, not sure about that one, which I appreciate. I think chat does as well. Harissa was wondering, Volcano Doc, if you were on call for any eruption.
No, I'm not. I wish. No. It's I don't work with any monitoring agencies, and so in the US that job is for the US Geological Survey. I would love to work with them, but I am not currently working with them. It's a pipe dream, hopefully, but also like there are other people who not so much like contract out, but maybe are experts on certain systems that if something gets rowdy, like there's one system where I might be, somebody might want to email me if the guy who's there, once he passes away, because he's really old, but he's like the park geologist and USGS. So like once he passes away, I might get an email maybe, but like there's not really that way.
That's interesting how it works. Like almost it sounds like it's a for life position.
Yeah, those jobs are really hard to get because they never leave. Ever.
Sounds like a tenured professor position.
They're the emeritus professors of industry.
Oh wow. Okay. Yep. That is a very good image painted. I guess, well, not desirable image, but yeah, I see the image there.
Mm-hmm. Yeah, volcanic royalty jobs for sure. Yeah, optic. So the Tonga eruption that I study, for the hour of its most intense eruptive phase, 80% of all of the electricity on Earth was generated within this very small area in this eruption plume. Like that's how violent and just powerful it was. It was an incredibly rare, one of a kind eruption, like genuinely like modern day Krakatoa, the 1883 eruption.
Is that and it all affected by climate change? Like, is there an increased likelihood due to that, or is that really you think it's just like one of those like really more of a one-off, non-standard kind of thing?
For this volcano, for Tonga, there is no relation to climate change.
Okay.
That is simply one of its every 1,000 years it has a really big caldera forming eruption, and this happened to be time. However, Iceland, on the other hand, the rate of magmatism it has increased slightly and is likely to continue increasing as climate change gets worse. And that's because Iceland is heavily glaciated. As Earth's atmospheric temperatures rise, those glaciers will melt. And because those glaciers will melt, you have to think of like a weighted blanket, right? If you remove the weighted blanket, there's less pressure on you, right? And so what keeps volcanoes from erupting is like the lithostatic pressure. You got to keep the pressure in, pressure has to keep it in. And so when there's less stuff on top, there's less pressure keeping it in. So I would say in places like Iceland or other places that have volcanoes that are heavily glaciated, like, if there's volcanoes in Siberia or like North Korea that are heavily glaciated, other maybe volcanoes in the United States that are well known for their glaciers. Chat, hit me. Chat, which one am I talking about? Chat, which one am I talking about? Which US volcano is heavily glaciated? Come on. And is right next to a major metropolitan area. Well, right next to is subjective, but really visible. Well known, not St. Helens. On the Washington state license plate. Come on, guys. Mount Rainier, there we go, yes. Mount Rainier is heavily glaciated.
So further climate change with that could yield, or presumably will yield, increased volcanic activity.
Well, it'll change the amount of pressure that's like it'll change the load bearing on the volcano that's kind of keeping the system in, which will basically make it easier to erupt. That's the change. That's the difference. It'll just make things easier to erupt. In places like Iceland that you are already dealing with like going from high to low pressure, and it's already high magmatism, you're going to just see more and more probably sustained rates of magmatism in places. Of course, this is over several hundred or thousand years. This is not a next week thing that I'm saying. This is a very long term, as glaciers melt, time scale issue.
I have a follow-up question for you on that. That may seem silly, but I've seen, there's like YouTube videos on it, and I'm guessing it's probably not real, but I want you to disprove it to me or prove it to me, Volcano Doc. The glaciers themselves, in terms of keeping the volcanic activity down, the temperature has nothing to do with that. Is that correct?
There's no relation between keeping the like it's not the water at all. It's just pressure.
Okay. So
and
keeping
and
it
like
cold.
I said, that is a very small amount. It's
okay.
With Rainier, it is heavily glaciated.
Mm-hmm.
I don't anticipate that climate change will trigger a Rainier eruption. I do anticipate that it would make it more susceptible to, it would make it easier for an eruption to occur once the magma chamber gets its, act together and gets primed for an eruption. Without the magma system being ready to erupt, nothing's going to happen.
Gotcha. And it's not maintained because of ice sheets or anything like that. Like, it's not the ice that has to do with it, it's the weight and pressure of it.
Correct.
Okay.
Correct. However, glaciers melting is a big hazard at Rainier because the big hazard is lahar. Lahar is the volcanic mud flow. So there's all sorts of like loose rock and debris and stuff. So as those glaciers melt, you're going to get more frequent and more severe volcanic mud flows.
What is a volcanic mud flow?
I mean, like a giant mudslide.
Okay, so it has nothing to do with like
debris that can be hot or cold.
Oh, it can. Okay, so it can be like lava mixed in.
Usually not. Usually, if it's a lahar, it's like hot ash that it mixes with rainwater or glacial meltwater, or if it travels across a lake, the ash will pick up the water. So with Mount St. Helens, when it erupted in 1980, the Toutle River was just dammed up with lahar sediments and stuff. It's buried houses.
Oh wow, okay. It's like a very aggressive mudslide.
Right. In 1985, the town of Armero, when Nevado del Ruiz, let me look up this number. Nevado del Ruiz eruption. 23,000 people died at once when the town of Armero was buried by a lahar in 1985.
Wow.
But this is one of the reasons why, like, if you live at the base of Mount Rainier in one of these little valley towns, like in Orting and stuff, when they're in school, they have lahar drills. They have lahar evacuation routes. They have lahar drills. So people who are within that hazard area, like, that's job, some of the jobs the USGS does is come out and talk to community members and say, hey, there's this risk. This is what you would need to do. They have lahar sirens on Mount Rainier. They have a lahar warning system because a lahar moving down slope has a different seismic signature than a volcano earthquake, than a tectonic earthquake, right? So they can see whether it's lava or lahar, or what's, look at the seismic signature to see what's coming down the hill. It's not, volcanoes are not something to be innately feared all the time. Volcanoes are wonderful, and without them we wouldn't have things like fertile agricultural fields. Like, I mean, we probably wouldn't even have life on Earth as we know it. We wouldn't have an atmosphere. I mean, they're amazing, and there is a lot of good that comes with volcanoes. You just need to be aware of the risks and know what to do if you are near or around one.
These Lahar mudslides and flows, could these happen in other locations as well that are maybe less monitored, so you wouldn't be able to have this kind of safety system put in place?
Yes.
Okay, so it is something where, like, the more I'm learning in chatting with you on today, Volcano Doc, is like that we need to have like these predictive systems in place because there's so many different factors that occur. Like you said, there's a tectonic one, there's a volcanic one, there's now this mudslide factor as one, and it just keeps like there's just keep more different things.
Call your representative and tell them you want to fund the USGS.
It's that's I think the scary part of thinking about it. It's not just like that it can happen, it's just almost like how unprepared a given area might be, right, to detect that these occurrences might be going on.
Yeah.
It's so actually, can we, do you mind, Volcano, if we get back to one of the original like questions of like what is the equipment that we have, like on this site here, it has like the cameras, the GPS, like what are all these things reading out to us?
GPS is a global positioning system, literally exactly what it sounds like. Just like on your phone, it tells you, lat long, elevation, things like that. A tilt meter came before GPS. So they install there's like, I'm not sure exactly where in the caldera wall it is. Yes, South Rebel, Planetary Pan is a scientist. I'm not sure where in the caldera wall it actually is installed because I've not personally seen it, but there remains one tilt meter that has been there since 1950 or so. They were first installed, I want to say, in like 1910, 20s probably ish. And it literally is what it sounds like. It's a tube of water. It's like a balance. Just think about like a balance where you have a bubble balance.
Mm-hmm.
It's like that. And it records the tilt in the volcano.
So I'm so sorry, Volcano. What do you mean the tilt in the volcano?
As the volcanoes basically breathe. I kind of think of them like people.
Okay.
Right? They've got magma plumbing systems. They erupt. They get gassy. Things like that.
Okay.
But when magma comes into the system, generally speaking, very generally speaking, when magma comes into a system, a volcano will inflate. And so the land will go up as it gets full. As magma travels out of the system, the volcano will deflate. And so the ground will go down. And so the tiltmometer, before we had GPS, a tiltmometer will measure the change in ground level. There's still one that's water that's remained for like to establish the longest continuous record of tilt meter, and then now the rest of them are electronic, on Kilauea at least.
Okay, so for when it's the GPS, you don't just mean like a physical, like here is our longitude, latitude, but almost like a ground. Like
correct. It's literally map. The position of the ground. We think of GPS as measuring where we are. Yep. GPS measures the ground, like it also measures like how far things move, so you can compare two dates and see how far GPS has moved, how fast it's moved, and from those changes in measurement, that's how we know like when magma comes in, the shape it is, where it is, things like that.
That is really really cool and a super useful tool. This like
Yeah,
I love the
very.
analogy of it like breathing how you said it. It's like this active system and measuring that and having like a long range of data to see like what exactly the states are. And I guess like reckoning back to when you have had an eruption, if you had all the data like measurements there, you can see like what yielded that eruption, like how much tilt was there, like what the speed of it was, and that's really really cool.
Hmm.
Harissa's wondering if the tilt meters are those in Yellowstone, so you can tell when the ground moves up and down.
There's not a water one, but they are electronic.
Nice.
The water one is that I know of is literally at Kilauea, and I only know that because I've done a Kilauea project. How far does the slide last? How far from Rainier do they need to evaluate to be safe? I think the farthest Coffee Rocks is like Tacoma, not barely Tacoma, maybe. You can look at landslide hazard maps and Lahar hazard maps. So there are like Rainier hazard map. Yeah, so there is a Lahar hazard map for Mount Rainier. I'm gonna pull it up real quick, and it shows like different runouts and potential extents and stuff like that. Um, yeah, so there's hazard maps like these for pretty much every volcano.
What does this hazard map mean, Volcano Doc? So it's like it looks like the red zone is like presumably when you're closest to the volcano. Is that like the worst of
That's
it?
the highest potential, like highest probability for Lahar,
Uh-huh.
because you would they travel like lava flows or like water rivers, anything that's gravity driven. If you have a very small amount or there's not a lot driving it, it won't travel very far. If you have a very large amount, there's some a lot of power behind it, you'll get a more far-reaching flow. So the yellow is just a much longer run out, much lower probability of Lahar's reaching that area, although there is still a probability, and that's what is important.
Gotcha. So it's like the red here is most likely where there would happen. Again, a likelihood
Yeah.
game. And then the possibility still exists that like orange is a little bit less likely but still likely, and then yellow is the least likely but still a possibility. So it's not like you wouldn't go to the yellow as a safe zone, let's say.
Right, right. And the other thing to remember is like stuff like Lahar's pyroclastic flows, lava flows, they go downhill,
Mm-hmm.
right? They follow topographic lows. So one of the best things you can do is go uphill. And uphill might not always be far away from the volcano. Uphill might be sideways. So that's why it's important to know, like, let's say if you go visit the Oregon coast on vacation, you're in a tsunami hazard zone. It's really important to know where to go, and that's up high. So you need to know where the nearest spot is that's not in a hazard zone, and sometimes there are like evacuation routes to follow up to the tops of certain hills because not all hills are the same. So I mean, it's stuff like this is kind of why I like to have discussions like these on Twitch, because you never know who's out in the audience that might find this information useful.
Yeah, absolutely. Or even like even if you're not on vacation, if you just live there, right? Like where are the resources
Well, if you
that you
live there,
can
hopefully you've encountered this before. But yeah, if not, then yes. Yes.
I think one thing, and I wonder if you'd agree with me on this, Volcano, because public communication is not the special suit of a lot of different places, especially like explaining what exactly the data sets mean. So it's like, okay, well, here you go. Like, here's some map that you need to be careful of, but there's not exactly a explanation of why you need to be careful or what the map means. Like how you just said it right now. Like, here's Mount Rainier. Here's like this circle of death, right? Essentially, or chaos. And then like the red zone is the runoff because of the directionality it's going, where it's going to be ending up at, why the yellow zone isn't necessarily the safe zone, right? Like going downhill on a topographical map. Like there's this depth to it that it's not that people don't understand it, it's just people who put these out don't necessarily invest that time to explain it.
Well, and correct, and sometimes they do, and sometimes maybe they don't have time to have the interaction that a community member might need to really understand it.
Yep.
Because when you're out there, and that's actually one of my jobs right now. I work as an outreach scientist for a conservation district, and you have events that are 2 hours long. You got to go at the end of 2 hours, and if a community member still has questions, sure, they can email you, but you're not going to have that interaction in real time that might be as valuable. And so the outreach scientists who are tasked with communicating stuff like this might be under those same constraints.
Right. And the likelihood that someone follows up in an email might be lower than the
Yeah,
in-person
every
interaction.
effort somebody has to take, like, I don't know about you, I am also, if I have to do things, like, yeah.
Yeah, it's we're very busy as it is. There's no time for that. No, but this is a really cool map, and thank you for explaining like how to read something like this, and just like
Yeah.
almost a PSA of like when you're going to one of these places, it seems like this is pretty freely and easily available. Like this is a really amazing website to be able to look at these different sites and like what the activities are. Like you said, like looking at the volcanoes and what the earthquakes are, what instrumentation's there, and like even the range of like earthquake age is really cool that you're able to filter this by, which I'm like, there's a ton of data here that is freely accessible to everyone.
It's all publicly accessible data, and it's all super open. They are very, very open, and because that's what we want public trust in the science, and that's why this website, I like it, so I love it so much. It's so open, and it makes that data available to everybody. So if you're really concerned about Yellowstone, you can go to the Yellowstone Volcano Observatory's website, and they even have like a Yellowstone Chronicles Mike Pullen does every month on their YouTube, and like they will literally answer all of your emails, and they're so amazing. So like if you have questions like that, oh yeah, the USGS, it's their website is wonderful. The disaster, like the hazard programs, are really, really well done and well run.
So one question for you, Volcano Doc, with these kind of public repositories that we have with the data, is the data standardized in any way when uploaded? So like I know for our end, like in the genetics world, like we have databases for like here is our fly genome database where like transcription data is here and like all these things, but it's not necessarily standardized in how it's collected, and so the interpretations can be difficult to compare between sites. How, if
They'll
at
put
all?
the raw data.
Okay.
You can get the raw data. So the databases. There are certain databases, where all this stuff is available, and no, Gwendolyn, let's not go there. Let's pick a different one.
What? Why should we not go to that?
I'm not legally allowed to say.
Okay, fair enough.
It's just been a little bit rowdy lately. But yeah, I forgot what I was talking about.
Oh, so like the data. So like if you're looking at like it within Hawaii.
It's the raw data. The raw data is there. So like with the seismic stuff, it's raw data, and then they do voodoo. The earthquake guys do their voodoo magic that I don't know, because I don't know how to quote read the wiggles, which is literally what a co-author's told me. Is like, oh, you just read the wiggles, and I'm just like, oh yes, thank you for that wonderful, thorough explanation.
This like on the seismometer, is this you see like how it's been moving around?
Yeah.
I mean,
they read the I don't know what. Yeah, they do voodoo, and yeah, it's just I don't know. They do their stuff.
Okay.
But there's different ways of like looking at the data. Yeah, I don't know what they do. They play with the data and can get stuff out of it, but you can download like the raw data.
Okay. So like, but is it fair to say when looking at this here, like the maps that we
all
have,
standardized?
Like, it is, so you can look between two different sites and it's a fair comparison to make because they've standardized from the raw data that came in.
if the other site has like the locations
Yep.
that yeah, it's just like the GPS locations of the
Gotcha.
seismometers and stuff.
Okay, see, that's something where like Danny was saying that there was like a paleontology repository similar to this, where like for dinosaur collection, one of the issues is like people and how they report it is very different, and so like you can get very different answers, and it's the same with like sequencing data, where even though like you've done some level of standardization, like the input data is very different, and so it's almost like you're putting in trash and caviar as your input, and then your output is like this weird mix of the two, and it's kind of hard sometimes to parse out what you can get.
Well, I think with other types of data like the chemistry data that I deal with, that can be a bit more complicated because the same types of data is reported, but depending on the lab and who's running it, it might not all be of the same quality.
Yep.
And so that's something that, you know, when you're a scientist and you work with labs and you get to know different labs' reputations and, you know, what labs are more trustworthy than others, and you know, then there's that kind of thing. But the numbers are all reported the same, and it's the same stuff that's reported.
Cool. It's just not a pessimism in me, but it's just like a nice little like data point to know of like how exactly like how much we can read into this data and the differences in the data collection. It's always something that I'm like curious about, because I naively, when I went into science, like, oh, you know, all the data is the same, everyone does all this great quality work, but there are these differences in there, and that's just like a nice little extra bit to be aware of.
Oh yeah.
With the other pieces of equipment, there is this gas measurement. What is that?
So those are gas sensors, and they literally are. We watched videos. I did this in July. I went to Albuquerque to the Valles Caldera, which is going to be a national park. It is an active, large-scale. We know what we know about Yellowstone by studying the Valles Caldera.
Is that
Take that as you will.
Is that okay? I was gonna ask like.
That means that there's just another large caldera that I don't like the word supervolcano. It's very misleading. There's a large silicic volcanic magma system in northern New Mexico. It's active. It's fine.
Okay, so supervolcano just means large.
It means that it has the capacity to have very large, very explosive eruptions.
Okay, but there's no guarantee one way or another. It's just like.
No, actually, if Yellowstone were to erupt, it would more than likely be a lava flow, similar to the Big Obsidian Flow in Newberry, in Oregon.
Okay, so is that, in your perspective, which is more dangerous towards people? I would naively think it's like the rapid eruption, just because of like a speed, and like, you know, blowing the side off a mountain and like debris that falls. But what would you say is like the more dangerous one?
I mean, what's your qualification of dangerous? Do you mean you want to have enough time to get everybody out and you don't care what happens to the property? Or do you want to preserve everything? Like, because if Yellowstone were to have a very catastrophic eruption, the kind that everybody's terrified of, there would be months, if not years, of advance notice of signs of this system getting reactivated and becoming eruptible enough, you know, becoming, yeah, so the magma is mushy enough and of a low enough viscosity that it can erupt, because at some point it's too viscous, it just won't. Like, it is physically impossible at some point for a almost fully crystalline magma system. It literally physically cannot erupt. So you have to get it to the eruptible point, and that can take a long time, especially with a very, very large scale system.
So that's interesting how you said define danger. I did not realize you can preserve property. I just thought it's just kind of, it's coming and that's that. How does
Well,
one?
it depends on the type of eruption, and
Mhm.
like with there like in Italy and Iceland and Hawaii, lava diversion barriers have been successfully used to reroute lava flows and protect property.
Oh wow.
But in a very explosive eruption, yeah, that's not going to do anything.
Because it's totally unpredictable, right, of where it's gonna land.
Well, it's just not going to do anything. Like, what is an earthen wall going to do when the ground's exploding?
that's,
Like, like, okay.
that's totally fair. Totally fair. Okay, nice. So the gas measurement.
Yes. So the gas sensors measure different volcanic gases and how their amounts go up and down. So, for example, two well-known volcanic gases are SO2 and H2S, sulfur dioxide and hydrogen sulfide gas. When a magma body is very close to the surface, like within the upper half a kilometer or less, you can detect sulfur dioxide. If that sulfur dioxide reacts with the groundwater system, it will react with the water, and instead you'll get a large amount of hydrogen sulfide, H2S, right? Instead of SO2. So the ratio of like H2S to SO2 can tell you whether or not a groundwater system is involved, right? Is the magma going, dealing with that groundwater? If you have a high, like your SO2 value goes up real big, that magma is very close to the surface. And that's how in Iceland in November we knew that the magma body had come in from below and was like 200 meters away from the surface, and then just sat there for a month before erupting.
Can you predict how long it's gonna sit there? Like that
You
month?
cannot predict anything.
Okay.
And I say that with force and gusto and much love and friendship, because a prediction implies a time,
Mm-hmm.
a place,
Yep.
and a magnitude.
Yep.
And that's just impossible. You can't predict any of those. You can't predict all of those things. You have to have all of those things for a prediction. So I just really like the term forecast instead.
Okay.
We can forecast an eruption with about this, really less, if it's a well monitored system, about the same accuracy as the weather. But most systems are not well monitored, so.
Uh-huh. Yep. I see. It's like, oh, it keeps coming back to how well we're monitoring a particular location, how long the data has been monitored, right? And then if you've had in that monitoring time some kind of event that you can plot against, like if it's happening again, we've already measured it once, so we kind of have the precursor of what's happening, and maybe there's a time frame to it. It may or may not be the same, but there's the data that goes accompanying with it.
Yeah. So let's say, and there's some stuff in chat I want to get to, but I want to, oh my gosh, I just had this in my brain. Oh my goodness. This is what happens when I've got so, like, my brain is very distracted. Oh, I'm sorry, I lost it.
No, it's my fault for jumping around so much.
No, it's not.
I'm just
No,
getting
it's not.
excited. I'm getting excited. For
Okay, what question?
for the odors, is it a mass spectrometer? Is that the machine that y'all have, or is it a very different machine?
There's different gas detectors.
Okay.
Usually you have to build your own. I didn't know that.
Really?
Yeah, there's no like standard gas. They all build their own.
So does that make it harder? Again, like the idea of standardization, if everyone's building their own custom machine, like I don't. How do you
Well, they all
feel?
measure the same. It's like the chemistry data. Remember, it's like they
Yeah.
all measure the same elements, but with what accuracy and
That's
precision,
the
how
catch, right? Like
reliable is that data?
how sensitive
That's where
is
you
it?
have to go look at the uncertainties and then make a good judgment call.
Oh man, I feel why it's that's amazing that you have to build something like that. Like I feel like again, this is just the naivete of like
Oh
how it's,
yeah, I remember what it was. Because you were like, "Oh, that's amazing. That's what got me."
hit me.
Okay, so Bulent, my question for you: how old is biology as a science?
Perfect timing. I get extra time to think of it. Raiders, welcome on in. Supreme Doom, how was your stream? Y'all, the lovely Supreme Doom is in his house. Card maker extraordinaire. Does speed runs of card making. Beautiful handmade cards. We actually are lucky enough to have a homemade card from Supreme Doom. We also have their lovely partner in crime, Shipwrecked. Kasima, hello. Mama Weissy, hello, welcome in. Shipwreck, how's it going? Supreme Doom, Raiders, welcome on in. Hello, Travel the World. Guys, if you're not following this lovely Supreme Doom, go drop her a follow. She taught us about Family Day in Canada the other day, and I don't know if you knew this, Volcano Dog, but there's a whole day in some provinces of Canada that you take to love on your family, and you don't go to work, and you just support one another. It's weird.
What do you do if you don't have a family?
You just hang out at home. Some provinces don't celebrate it because they don't have families.
Oh, I was actually asking seriously. Like, that's kind of sad.
No, I guess you just get the day off work.
That's not bad.
Aaron Canny, welcome in. How does... Shipwreck wonders how you, Volcano Doc, feel about me yelling Raiders.
I'm used to it.
I'm so sorry, Volcano Doc.
That's fine.
Sally Salt, first time chatter, welcome in. Welcome in, Raiders. My name is Belent. I'm 1/3 of SciAnts streams. The other 2/3 are my wife, Lita, and our daughter, baby Alona. Lita and I are PhD geneticists, and we're joined today by the lovely Volcano Doc. She has her doctorate in volcanology, geologist extraordinaire. We're talking all things volcano science and learning a ton about where really the gaps are, I would say, about like how the best way is to detect volcanic activity, to prepare for it, and where we have fallen really short on it. And lots of data, lots of fact-driven things that Volcano Doc is showing us. If you have any questions, feel free to ask. And also, I can't yet give her the fancy shout-out, but below in the channel description, there's two hyperlinks that you can click on Volcano Doc's name and drop her the follow. My challenge to our community today is to blow up her follow alerts and make her computer crash. So if y'all could do that for me, I'd very much appreciate it. Sabrina News says, Ship started my stream working on StreamerBot, and then I took over, made 2 speedrun cards to test out the new timer Ship made me. Nice. How did the Ship made timer work? And Shipwreck, no. StreamerBot not the best bot. Clearly SammyBot is the best bot. You know, we have this for chat coming in, we have this silly disagreement because BitGamey uses StreamerBot and I like to hate on StreamerBot because it makes him, upset, and so then I just continue to do it. We also use SammyBoard here, and then BitGamey gives it right back at me. But Raiders, welcome in. Supreme Doom. If there's anything you'd like to share, please feel free to share it with us. And again, if y'all have any questions, Raiders coming in about volcanoes, geology, and the hottest stream on Twitch, which is on Volcano Doc's channel, please feel free to ask. She was just asking me how old I think biology is as a study.
Yeah.
And
as a science, how old is biology?
What are we defining as biology?
Whatever you do, like genetics, how old is your study? That's not really fair. Like I don't know. This biology is a science.
Because I would say like the Greeks even would have had some level of biology, because there was like even like talk about like potential features of animals. But if I'm actually going to like fruit fly science, that's early 1900s.
Okay. All right. Fair. Touche. I was gonna say like geology's young. It's only been since the early 1900s.
And why is that? Like what I see, because that surprises me. I would have thought that there would have been some other kinds of flavors of records.
Well, I guess so. Geology. Well, geology as a whole, late 1800s.
Okay.
1800s. Volcanology, 1900s.
Really?
Mm.
And why?
as a science,
Yeah.
that's when the Hawaiian Volcano Observatory was established.
Mm-hmm.
The Etna Volcano Observatory was also established around that time, but seismometers weren't invented until like the 1890s.
So it was an equipment issue.
Our technology is very, very new. We didn't understand like modern geology. So I guess, so the way, like, how you're like, oh, biology back with the Greeks. I'm like, oh, geology back in the 1880s. Modern geology, like genuinely modern geology as we know it now with the theory of plate tectonics, has been around since the 1960s.
Okay.
The lady who, the gal who was the first female research scientist on an oceanic research vessel and literally figured out how the San Andreas Fault formed, is a professor emeritus in the department where I graduated with my PhD. Like, I've met her, I've won a scholarship from her. Her name's Tanya. She's super dope.
That's awesome.
Like, she's really awesome. But my point is that's how young it is.
Gotcha.
Like,
Okay.
it's a we've like it's like our modern science is only 60 years old.
Okay.
We don't know very much.
Okay, so with that definition, it's like, Sally, thank you for the follow as well. And so Sally said, so with ancient cultures studying medicinal effects of plants be related to biology. See, that I thought, like, as the broad study of biology, yes. Kind of, this is why I like equated, like, even the Greeks, or even, like, the first microscope seeing a cell underneath, like, with cork. But if you're talking about actual, like, some kind of foundational genetics, that's the early 1900s. When they're making the first mutants intentionally with fruit flies. And so,
Yeah.
even with though, definition, geology and volcanology are really, really young relative even to that. And so it seems like it's a establishment of the field by having a proper location to study it in. And two is like the actual equipment to be able to detect things like in anticipation of or during an event versus just like, oh look, it's fire.
Yeah, and our technology is still super rudimentary. Like, we are so limited in our capabilities now because of technology. We don't have anything that can drill into the like deep into the mantle. Our drill bits melt. You know, at some point the pressures and temperatures inside the earth are just too much for what materials we can create that make these tools. We genuinely cannot get at the data because we do not have the technology.
That is super cool. I mean, it's frustrating. It is really. I bet it is super frustrating. But like, I had never considered that it's like you're limited by the fact that if you start drilling deep enough, it just melts. Like, what are you gonna do with that?
Yeah, and we've drilled into magma chambers on accident. Like, once in Kilauea at the Puna geothermal field, they drilled into a dacitic magma body that was melted partially. At Krafla, the caldera in northern Iceland, there was a well borehole and a magma body that was moving intersected with the well borehole, and magma like came up and it ruined it. Like, it ruined the borehole. Like, we just that's high temperature things, you know.
Yeah,
Humans are very, very tiny.
So even like all this equipment like on this map that we're utilizing to measure,
a lava flow will take all of that out.
Exactly. Yeah, so it's like, even would you say that this measurement is very coarse almost? It feels like to me it's like coarse. It's not especially like super fine, like, because you can't get to it, right? I think it's all like causality.
I mean,
almost.
for our capabilities, it's very, very good. It's top of the line.
But like, I don't know, I guess I keep comparing it back in my mind to genetics, right? Of like what we can do. Like, I can turn off a gene and figure out what happens, right? And it seems like here it's just like very 1,000-foot. Do we have heat in the ground, right? You were saying like a presence or absence of heat, or the tiltometer, right? It seems like it just again, this, I think, is cool that we're having this conversation, right? Because it just, the field's status is so different of what we consider like honed in and like good, like good pulling out of like nice res data, you know?
Yeah, and planetary and chats, like, I haven't even talked about the underwater. Like, when you have underwater stuff, it's so expensive, and so there's so many volcanoes underwater that just aren't monitored at all. Like, we don't even know about some of them.
Okay,
Like,
could you tell us about
we haven't
some
mapped
of the,
out the ocean all the way, really.
tell us, Volcano Doc, about the underwater. Because actually we did, y'all, we seem like we're loosey-goosey. We did talk a little bit about ahead of time of things that we could chat about, and part of it was these geothermal vents. But like I see, like, you know, we looked at this video of this underwater eruption, right? What are the equipment pieces that are down here? Like, presumably it's not the same as what we saw on that map a minute ago with the cameras, tiltometer, seismometer.
They're special. I know the seismometers are specialized, and Planetary and Deep Earth, if you guys are in chat, please feel free to chime in because they've got way more experience. I've never dealt with underwater instrumentation myself. But it's my understanding that, like, they're really expensive because they have to be maintained. They're under extreme pressures, and you also have to get the data back to the surface. So there's like cable lines that could be torn that also have to be maintained. You're really limited by, like, in terms of gases. Like, what are you going to do? It's going through water. There's no point to try to measure it, because it's your signal's going to get contaminated. Yeah, I mean, tilt meters, and you don't really have GPS underwater. Now they have fiber optic seismometer sensors that are like literally brand new within the last like 5 years. I don't really understand how those work, but I believe they can be used to monitor underwater volcanoes. Oh yeah, that's where the infrasound comes in. Thanks, Planetary. I appreciate it. Yeah, infrasound, because the sound waves will travel really well through the water, and so you can measure those fairly well.
Okay.
You can use infrasound to even detect like where on a seamount the vent is erupting from.
Wow. Okay, that's like a nice higher resolution measurement that you can get out of it.
Yeah.
Is there an equivalent map like this for underwater stuff?
Not that I know of.
Okay, that's too bad because this tool is super cool. Like,
you might be able to zoom out. I mean, if you go to like the regular page, you might be able to zoom out and see if there's any seamounts. Like, go down to the right. No, to the right. Yeah, that seamount down there, Loihi. Well, it has a new name now. I don't remember it.
This one here.
Yes.
That
is the newest volcanic island to be. That is where the hot spot is erupting now, from like there in Kilauea, because the plate moves over the hot spot. So, like, in probably 100,000 years or so, that's going to be a big island.
Okay.
Or it'll be part of the big island.
Yeah, at least there's nothing mapped out here. Planetary says it's only for volcanoes that have been mapped. Okay, so this would be an up-to-date resource for when we have something available. And again, I feel like...
Yeah, I mean, they're the resource. They are the resource.
Okay, so it's frustrating. It keeps coming back to the resources that we kind of want just aren't there, right? Like, or not enough at that particular site. And I think, Chad, if you can take anything away from today, it's how complex these things are, like in terms of predicting volcanic activity and like the
forecasting.
She's gonna teach me by the end of this stream for me to say the correct word. Forecasting this to the best possible likelihood. And so if you don't have these tools, that's never going to happen.
Right. Yeah, and that's so important for people to understand. That, you know, as scientists, we can try as much as we want,
just
but
subscribed for 12
the instruments and data aren't there, we don't have any ability to help.
Thank you for such an amazing 12 months.
Dilly the Dough, thank you for the resub for a year. Appreciate the heck out of you, Dilly. You get a piece of raw science put into the beaker. Thank you, Dilly. Did a whole year. Thank you, Dilly. Dilly, we're joined today by Volcano Doc. For anyone coming in, Volcano Doc is a PhD research scientist in volcanology. She is the expert on Twitch. 100%. She live streams every Sunday, and Saturday's coming too, where does live Q&A, does live research like editing papers. And anyone coming in from the home page, which we just hit on, please consider hitting that follow button on Volcano Doc. Her name is highlighted in the chat, and as soon as I can do a fancy shout out, which might be now, let me give it a shot. Y'all, please consider dropping that follow. My challenge for you tonight: blow up her follow alerts. 57 seconds. To the point where the computer crashes and she has to relog back in. That's what I want to happen. Can it happen? I don't know. The Twitch API is pretty strong. But you know what? If anything, we can figure out a way to break it. Dilly, thank you for the 1 year resub, my friend, and we'll get you your fancy shout out as well in just a moment, Dilly. Thank you for that ongoing support and for supporting our other scientist friendos here on Twitch. The lovely Volcano Doc, who's here teaching us all about volcanology and, what we need to, not really be worried about, but just to account for and think about when it comes to, the geological sciences. And it's an absolute privilege to have her on, but her explaining these fundamentals to us is super exciting. And it's just, again, it's a privilege to have you on, madame.
Well, yeah, I'm happy to. Hi, Dilly. Thank you so much for the raid. Planetary, your master sounds so cool. I'm definitely going to have you on to talk about it. I'm very interested in hearing about it.
By the way, Planetary Pan, are you also a streamer?
Yes.
So
yes.
They've been just answering questions without alerting me to this without us being able to give a fancy
shout
out.
Go follow her.
All right,
She's a planetary scientist.
All right, Planetary Pan, we're going to get you a fancy shout out in just a moment because I can't be having this kind of shenanigantery that there is this, special person here and they're not getting. No.
I don't. CosmoQuest X.
Well, you know what? We're gonna do both Planetary Pan. We're gonna blow up both of them. All right? Because I can't be happy having one or the other. But guys, Volcano Doc, right now, heart button at the top of the chat. If you see it and it's not clicked, that means you're not doing life right. And please go follow her. I am unofficially launching her partner push. And she's
yeah. I mean, if I can't, I'm looking at professor positions right now. If I can't, if a university doesn't nab me up, I'll be freelance research sciencing on Twitch.
There are worse things, and you are very good at what you do on Twitch.
Well, thank you. I do need to ask if we could take a very quick break. I have a very old chihuahua that just woke up from a nap, and I would like her to go to the bathroom out of doors.
Absolutely, y'all. We're going to take a quick BRB. I am also an old chihuahua who needs to use the restroom. When we come back...
you want to look at stuff under the microscope when we come back? We got that, 2 billion year old rock to look at.
I can... Yeah, I'll switch up the cameras and have it ready for you when you come back.
We can also still talk about volcanoes while we look at that, too.
Yeah, absolutely. Perfect.
Cool.
All right, y'all.
Okay.
Give us just a few moments. We'll be right on back. My name is Halter. Oh, I hate this poop show.
Very sophisticated.
Mocha, one mic. Hi, Yogurt Carol!
See your butt.
Well, that's for the Antonia butt wiggle, That offspring can breed as well. And what's coffee
cracks at them, and it.
Theo is amazing. Theo is so kind. There's no underpants worn by these animals. Every other name we go, Biff Dougie, Jern. Barty, Jern. Claire, Jern. Date Night In, Jern. Big Gaming, Jern. Jern. Actual education, welcome in, Raiders!
Science stream, but we ain't bugging. We over here about to leave. You be chugging what we got. Now the tribes arrived. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Raiders, welcome the heck in. Actual Education. Apologies, I had just stepped away running to the restroom. Welcome on in. Raiders, how is your stream, Actual Education? Tell us all the details. My name is Belent. I'm 1/3 of SciAnts streams. The other 2/3 are my lovely wife, Lita, and our daughter, baby Alona. We're research scientists, and we do interactive live science streams here on Twitch 7 days a week with microscopy, art, sci-fi, science, science news of the week, deep dive scientific topics, games, 3D printing, IRL streams, model building, and more. Today we have on Volcano Doc, Professor of Volcanology, and we're discussing fossil science. And yes, NME Soldier, Thug Shells made our theme song as well. At the beginning of every stream we play a theme song, and here's a clip of our theme song just for you. I'll give you a freebie.
SciAnts. We get experimental science. We're curious, not judgmental. Always good vibes when science on screen. Time to learn live with SciAnts.
Miss Shells is a bestie, and so we do a lot of custom sound alerts are from Miss Thug Shells. Actual Education, welcome in. AS Monkey, an MS Monkey, welcome the heck in. Actual Education, how was the stream? What were y'all up to today? Folks, Volcano Doc is taking a quick BRB as well. I'm going to get the microscope set up. It does mean I have to move Socks the cat around. Socks the cat is sleeping on my microscope chair. So we're going to move her around. We've got some samples to look at under the scope as well. Volcano Doc is going to tell us about the samples, which are really cool and really exciting. One is over 1 billion with a B years old, which is, again, super phenomenal to be able to have something like that. But yeah, y'all, thank you so very much for the raid. As I'm setting up stuff, I'm going to play y'all a quick channel trailer just to give folks an idea of what the stream is about and what we chat about here as, again, I start shifting around the cameras and things. So we will be right on back. Actual Education, please let us know what y'all are up to today. Again, we'll be back in 60 seconds, y'all.
Welcome to SciAnts Streams. If you are interested in all things science in a fun, wholesome environment, you are in the right place. SciAnts is a unique husband and wife team of Belinda and Lita, who hold their PhDs in molecular and systems biology from Dartmouth. What can you find here? The SciAnts team is dedicated to making science more accessible to our entire community. They believe that it is the responsibility of scientists to engage with the general public, and Twitch is one of their media doing this. By showcasing their own research, highlighting new discoveries, answering viewer questions, and sharing their passion with you. We do a variety of interactive science streams, including microscopy of ancient amber with insects, 3D printing, art, science news and deep dives, the occasional game, and more. If you've ever wanted to have a fun space to nerd out, now is your chance. We stream daily science content here on Twitch. Understanding not just what we know, but how and why we know it is the essence of scientific knowledge. Check out the About page for more information, and consider hitting the follow button to join our colony and our mission in science for all.
So again, y'all, welcome in. I'm just going to quickly change around some cameras. Alrighty. Move Volcano Doc here. Look at that. It's like fast actions right here. Boop. And then... look at that. It's like we've shifted positions, Volcano Dog. Actual Education says, Monday is always a long stream. We had a fun variety, math, physics, and homework questions. Nice. What was your favorite, Actual Education, on the topics that you discussed tonight? And Good Enough Painting, thank you very much for that follow. Welcome the heck in. Just getting the microscope set up. How's the Chihuahua, Volcano Doc?
She has been successful, but still refuses to eat her kibble left over from breakfast.
Oh, the joys of pets, right?
She's holding out for something better. She does that. Once she realizes she's not going to get anything better, she'll eat her leftover kibble and then look at me because dinner's so late.
How dare me.
I know. I'm a terrible... She comes and gets me and is like, it's time for bed. I'm going to bed. It's time for bed. You come to bed right now. I know when 9 o'clock hits every night. She's a very old lady and set in her ways.
Munchkin started to do that this past week, where before she was eating all her food without any question, and now it's... she's not really feeling it. She's like, some of the food, she's like, I'm like, you're a little baby. What do you mean you're not feeling it? She's very much getting to that point where something's not, she's just not feeling it.
You are in for a good, like, minimum 4 or 5 years of fun.
My mom was like, who's a pediatrician for chat, she's like, well, it's she's starting early, but yeah, it's that toddler phase. I'm like, it's a year early. And she's like, yeah.
She's advanced. Look at her parents.
That's why I totally she takes after you.
See?
I mean,
My best friend's son, he's 5. No, he'll be 5 this year. He's almost 5. He is on an orange kick right now. He ate like an entire bag of cuties in an hour. Like she made him like learn to peel them because she's not doing that, you know, that's insane. But so he ate an entire bag of cuties in like a stupidly short amount of time, and then the aftermath was very, very orange. Very, very orange.
The aftermath, I love it.
So I will tell you that is a toddler, like my spawn did that with blueberries. She will not eat blueberries
Anymore?
No, like as a grown up, like, or as like a older kid, she would not eat blueberries because when she was like 3 or 4, we took her blueberry picking and she ate like 5 pounds of blueberries at once, and the aftermath was very blue. And literally, she will not eat a blueberry. Period. It's so funny.
For a few weeks, Munchkin's favorite thing was a blueberry. And right now we're at the stage where, like, you know what? I don't really like blueberries anymore. Like, what do you mean? You've just been eating them.
No, I've never liked them. What are you talking about? You obviously remember wrong, Father.
Papa, come on. She loves cheese, right? That's the thing that hasn't changed. Is an immense, absurd love of cheese. Which
reasonable.
Yeah, I mean, I also love cheese, but this is like an insane amount of cheese. Speaking of cheese, this is not cheese. Volcano Doc. Guys, I won this from Volcano Doc's stream. One thing you can actually do is she does monthly raffles. You can either buy a ticket with channel points, or you can be subscribed to enter. Let me know if I'm getting anything wrong, Volcano Doc. And I was lucky enough to win this sample that is over 1 billion with a B years old. And so, Volcano Doc, I was wondering if you wouldn't mind kind of walking us through, because like I read your note, right, and I have your note still here because A, it's precious memories, but B, it also tells me what the sample is. But I would just love to ask you why this is special.
It's really cool. So stromatolites are amazing. So the fossils we're looking at, these are stromatolites. They don't look like very much. Hi, Misadventures. Yeah, they don't look like very much, but they are some of the earliest life forms on Earth. These are 1.7 billion years old. These particular stromatolites, you know, that's old, but that's not like the earliest life form old. Like, I have genuinely touched the oldest ones. Some of the oldest stromatolites are from Australia, and they're like 3.4 billion years old.
Wow.
And those stromatolites are literally the reason we have an oxygen-rich atmosphere.
So, back me up for a couple of minutes. What is a stromatolite? Just in like
stromatolite is an kind of like an algal mat, but it's not an algal mat.
Okay.
Because it's not algae. It's cyanobacteria, and it like sits on the ocean floor, and it builds up like a little kind of like sedimentary bacteria goop mat. And
is it
over
like
time,
some kind of like membranous goo almost that it's around? Like I kind of want to harken it to like a filament that like is kind of in like bacteria in our lungs and what they end up doing.
I have an idea. Why don't we watch this?
Okay. Travel the world, Travel, thank you for the tier 1 gift sub to Shipwreck. Thank you, Travel the World. Let me grab a piece of raw science. Yeah, hi, beautiful socks. Hi. Yeah. Wait. Someone has woken up from her nap. Yeah. Travel the World, thank you for the gift sub to Shipwreck. Shipwreck, enjoy the ad-free viewing and the emotes made with love. Nelly, thank you for the lurk. Let me go ahead and grab... Oh, hi, beautiful. Yeah, hi. You want to say hi? Okay. Okay, you can say hi, huh? What do you think? Volcano Doc, you're giving a look. Like, she's a naughty sock. Free I love the free socks emote.
It was nothing to do with you. It's nothing to do with you or your socks. It's just so funny because like I had just made that a custom emote for a community member, and it was just too good. And you were so confused, and it was amazing.
I really was. And I love that it's also one of your Discord emotes, because then it's I see it, I'm like, where is this coming from? Why? Why is this a thing? Poor socks.
Nope, nothing to do with you.
It makes me so happy, Volcano Doc. Like, emotes are one of the reasons why you're right. You can justify subbing to a stream, like if it's a good goofy emote. And honestly, my favorite of yours is the cake.
They took it away again.
Wait, no, it's gone. No, don't lie. No. Who's the jabroni that's reporting your emotes?
I don't know. Somebody's smelly. Somebody's smelly, and I don't appreciate it.
Y'all, you know what we do to smellies?
Speak up.
Yeah, we got to get rid of them. We can't be having smellies in Volcano Doc stream. I'm sorry, Volcano Doc. I love that emote. It's such a good emote.
I know. No, they took it away.
It's one of my favorite emotes to I would always let it loose at Irish John's stream. Cause he's always like, and he always goes, Blint, stop it! And I just always just do those kinds of emotes on his stream. It's like, where do you get these emotes from? Or like lick emotes. Those are also like gold to be able to drop. And he's just like, Blint, stop it!
Those are fun. Those are cute.
It was one of my favorites to be dropping everywhere, especially if it's as like a first time chatter. Just drop some of the cake emotes. People like, what? And then it's like they click on it. It's a volcano. What? And then it's just you got them hooked, and that's the power of SciComm right there. And I
know.
I always tell you how much I enjoy. I'm like, man, I really really enjoy that emote. All right, so let me know when you're ready, and when clicking this, like if there's a pause point that you want, let me know. Otherwise, I'll probably just be interrupting myself.
No, it's just a really really great video that explains like what they are,
okay.
And it's like super academic, so it may there might be a need for us to explain things, so that's fine. If you feel like there's something that you don't know, or chat, please speak up. If you want me to explain something, but this is just a really great explanation. Also, not my field, so probably way better than I can give.
Well, when we're looking at the sample under the microscope, like after we're done watching the video, could you show us where, like, the zones of importance are almost on the fossil?
Where the what?
Like the zones of importance, like what is like.
Oh.
What is like a slab of dirt versus like
yeah, we'll take a look at that. We'll talk about that when we look at them.
Excellent. Excellent. All right.
Some of the oldest evidence of life on Earth comes from a very unusual form of sedimentary structure known as a stromatolite. Stromatolites in the Archean provide evidence of early life. But stromatolites occur throughout the geologic record too. And they still exist today, even if they are relatively uncommon and limited to a narrow range of environments. What are stromatolites? Stromatolites are mound-like bioaccretionary structures. Bioaccretionary structures form when organisms aid in sedimentation.
Dude,
and
this is really, really
electrification.
boring.
In contrast
I feel so
to
bad.
sedimentary structures
Why? No.
that form.
It's so when you were out because this
Academic. I feel bad.
No. Did you look? It has 6,900 views. Someone must be doing something right?
Okay. All right. If okay, as long as chat, it's for me. It's the monotonous voice. I thought that this was a different video. It was not, and so it's still really, really good. It's still really good. It's a college-based video. It's like a college course-based video, so it's like super duper accurate. It's just the monotonous voice.
So
I'm gonna turn the speaker down and let's just continue watching.
Well, so a question about the sample that you collected. Well, I guess number one, is the sample that we're looking at a piece that you collected? And then two, did it look like this of where you got it from? Like, is this a representative look? Like, what is the locale in which that you found it in? You know what I mean?
Yeah, great question. It was the third shelf of the back right corner of Handley's Rock Shop. And
oh God, when you said shelf, I thought it was like ground shelving, right? I was like, what is? That's like a cool geological name of like.
No,
okay.
I bought it. No, I went with one of my mods came for Thanksgiving, and I went to a rock shop because I do a lava lab giveaway every month, and I was like, oh, I want to have some cool new samples to give away because I've kind of run through the gamut of what I've got, and then we went and I got some like little stuff like some minerals and little like rocks and things, and then I found this box of stromatolites, and I was like, are you kidding me? Like, this is just for this. Why is this box full? You know, so I have quite a bit.
Was this something labeled, or did you just like recognize it as stromatolite?
They were labeled stromatolites from Wyoming.
Wow. Okay.
And I know what a stromatolite is.
Cool.
And I know that the fossil stromatolites are going to be billions of years old.
Okay. When we go back to the fossil, just as a primer, I would love for you to tell us how you know. Like, obviously, you are the expert, right? Like, your eyes
the box
are trained
said
for
stromatolites.
This. No. You know, I'm trusting you, Volcano Doc, on this. Of like, you know, like why. Like, what is the cool?
Like, how can I look at the fossil and tell?
Yeah.
Okay.
Yeah. Okay. Cool. I'm stupid excited, Volcano Doc. I can't help it.
Okay.
From sediment in motion, like wave ripples and desiccation cracks. Bioaccretionary structures only form in the presence of life. If you cut a stromatolite open and look at it in cross-section, you will see that the mound consists of layers called laminae. These laminae are built up into columns of sediment. The mounds form in shallow...
These right here, these are the columns. If you were to cut one of these in half,
this here,
that's what you would see.
Gotcha. So like one of these on the image now.
Right.
Uh-huh.
Yeah, and these still exist. Stromatolites are still in existence. They're just not common. I think the ones that are still around now are in Shark Bay in Australia. And that's where these are coming from. But I think Enemy says the volume's a little low on the YouTube. Would you mind turning it up?
Yep, I just boosted it. Thank you, Enemy. Sometimes the feedback, like, it doesn't come through in my ear, so y'all letting us know what needs to be fixed is really helpful. Thank y'all for that.
Yeah, thank you.
So that's really cool. There's still modern ones existing as well. That's like super exciting that something like that would still be around today.
Yeah, they've been around for literally all of life on Earth.
That's the other thing too. Is like you're telling, it's like billions of years old and they're still around today. Like they must be
cyanobacteria, man.
Yeah,
bacteria are. If we're gonna find life on other planets, it's gonna be bacteria.
Oh, that's really like how successful they are, you're right, of how long they've stuck around is pretty remarkable. Just to think about, like you were saying, with geological time, right, like the 300 years that there has been a flow, and I was like, wow, that's very long. You're like, no, actually, like, think about it, that's like a blip, right? But these have been around for more than that blip, like almost
Much more. Most of Earth.
Yeah. Oh, that is so cool. It's so cool.
Yeah. But that also tells you what else? That tells you if these are forming in this environment now, then 3.4 billion years ago we had shallow oceans.
Okay. I guess the biologist in me asks, how do we know that? Right? And this will be like why our two disciplines are coming together, right? Because in my mind, it could always be the evolution of going towards the water, right? Versus from a different source. Like, directionality isn't necessarily implied, but presumably
Because they're found in marine sediments. They're always found in shallow marine sediments in the fossil record. So every time that they're found in the fossil record, they're found in the same environment. Therefore, it's very reasonable to assume that the same biological processes are happening.
Yep, that answers it, right? It's like, it's that hybrid answer of, like, the way that you know is looking at where these fossils are found, right? And presumably that can tell you if it was in the waters or not. Because they were in the water, then you look to these, like the modern ones.
Turn yourself up.
Oh,
Sorry, you're quiet now. I think when you left, like something changed with your volume.
better. Sci, thank you for that.
Enemy?
Yeah, enemy. That better. Worse. Me being quiet is not standard. I'm usually the one shouting. A little more. All right. 1 or 2 misadventures. 1 or 2. Do I put on a phony baloney accent? Or what do we do? Thank y'all for the feedback. All right. Good
We
now.
do appreciate it, genuinely. It makes a better stream.
It really does, yeah. Like, it's not imposing to say, like, please let us know. Like, this is a show, like, a good production value, and it is very important. And we all try our best to, but sometimes there's just no way of telling except if you're on the live end of things. And I could have an earbud in to hear me back, but God, that would be irritating. like on that delay to check and see. So y'all giving us feedback is huge. And Putrick, welcome in. Putrick, we got Volcano Doc here, a real life volcanologist who's answering questions, and we're gonna be looking at a 1.7 billion with a B year-old fossil, and this is what's inside. This stromatolite is inside one of the oldest forms of life that's still around today, which is
Hi, Portrait.
It's super gnarly that this is still a thing.
Yeah.
The water. The inside of the mound is rock and sediment, but its exterior surface is covered by thin layers of microorganisms called microbial mats or microbial films. These mats grow and develop on the surfaces of stromatolites and cause the mounds to form and develop over time. Although the stromatolites themselves are solid rock and sediment, the mats have the consistency of a gooey mucus. This mucus is due to the presence of an extracellular matrix secreted by the microorganisms.
So see, that mucus has me interested because that's very much sounds like one of those like membrane external organelles that even like cystic fibrosis, like colonizing Pseudomonas grow in. Like these membranous jelly-like layers is like almost a protective barrier for bacteria against external pathogens or external stressors, and that's like a very ancient form of protection. It's just really cool to see like that's the same mechanism of action here. Like that is the reason presumably for this like gelatinous cover, which again is like
If it ain't broke, don't fix it.
Yeah, absolutely. That's why we see all these repeating features throughout time.
These microbial mats generally consist of cyanobacteria, filaments or chains of microscopic bacteria that do photosynthesis, converting sunlight, carbon dioxide, and water into oxygen and food. The mounds are created by microbial mats. When sediment is deposited on top of the microbial mats, they become bare and die.
Professor Danny Anduza coming in with a raid. Welcome in, Raiders! Danny, how is it going? How is your stream today? We got Werewolf Cast, we got Real Men Grow Beards, we got Buttsbot being highly inappropriate, pulling stuff in. Dame Karen, hello, madame, welcome. Sloppy Salamander, Tommy Plodicus, Jody Fish, welcome, welcome. We got Nowcar, welcome in. Henrida, Reagan Nation, hello. Geo Jim coming back. Svarkin, hello. How are y'all doing today? Welcome on in. Professor Anduza, how was your stream, my friend? Saw you on the stream, had to rate it. No. There's no interruption, Danny. For you, I think.
Hey, Danny.
Volcano Doc and I would both just drop everything at this, at the drop of it, right? Yeah. You just send us like a ... message. Like, well, yeah. Hi, Dino Dave.
We're talking about stromatolites, Danny.
Yeah, Raiders, welcome on in. You're here for a very special crossover stream. So my name is Balint. I'm 1/3 of SciAnts streams. Other 2/3 are my wife Lita and our daughter Alona. So Lita and I have our PhDs in molecular biology, and we're joined today by the lovely Volcano Doc, PhD in volcanology, which you might be like, volcano science and biology, what is happening here? No. Right now, so we're looking at stromatolites. We have under the microscope for the Raiders coming in this fossil. We're going to dissect what exactly we're looking at. Asaziz and P-Lander, thank y'all for the follows. This fossil is 1.7 billion, with a B, years old, of cyanobacterial remains. And we're watching a video right now about what exactly this means, what is kind of the geological history, if you will, and how it corresponds to the existing fossil that we're looking at. Yes, and there is a microscope behind Volcano Doc as well. Not the one that we're currently using, I promise. It is real. See, we've got the sample here. Wiggling it around live. We are joined by Volcano Doc. For those coming on in that don't know Volcano Doc, you're missing out. She is the premier volcanologist on Twitch. Does live science content every Sunday, and soon to be Sundays and Saturdays. She was on the TwitchCon panel with me, Danny, Nerduino, Moohoodles, where we were advocating for science on Twitch. And she is a gem of a human, one of the best in the biz. Please go drop her a follow. I cannot yet do the fancy shout out because it's every hour, but in the channel description today, there's 2 hot links that you can click. There is our little description and the stream together. You just hover over her name, you click. If there's the heart button and it's not filled in, that means you're not doing life right. You click it, and all your dreams will come true, I promise you. I am unofficially launching her partner push today. She had no idea about this. This is not necessarily endorsed by Volcano Doc, but it will. We're gonna.
I'll take it.
We're gonna get her to
You never know what's gonna happen. You never know.
Absolutely. Danny says, stromatolites don't get nearly enough attention. Yes, and it is super exciting to be able to have one underneath the microscope, and we're chatting about, where they come from, and Volcano Doc was showing us this really cool video about the background information on it. So again, y'all welcome in, folks. I also can't give a shout out to Danny right now. It's on cooldown. But Professor Anduza, I think Volcano Doc will agree with me, is like our SciComm inspiration. He's the one who pioneered science on Twitch, live paleontology, 5 days a week, as well as like field research streams, actually collecting fossils, art, video games, just the absolute best of science on Twitch. If y'all aren't following Danny, you're not doing life right. Like, I know we wouldn't be here without Danny. And so, Danny, thank you for everything you do, my friend. And we will get you another fancy shout out as soon as the cooldown is done, because I can't tell you how much, Lita's first stream that she watched was Danny's stream. And it was her and one of her best friends who, we live separate states apart, couldn't hang out, and the whole hanging out started again in Danny's streams, on the weekdays. It was like, oh, you're "You gonna be in paleontology?" "Yeah, I'll be there. I'll see you there." And it became an event, and it still is. And so, Danny, thank you for everything you do. So we, paving the road for myself. And we got another raid!
Double raid, whoa!
We got a double raid from Ginger Crush as well. Ginger Crush, welcome in. Oh, and Jim is coming back. Eldarin, welcome in. Ginger Crush, hello, hello. Ginger Crush, how was your stream? Tell us all the things. Ginger Crush, what were y'all up to? Just chatting. What were y'all chatting about? Raiders, welcome on in. Ginger Crush and paleontologizing. We got double rated, guys. Go check out our friend Ginger Crush as well. Volcano Doc, if you don't mind, we're going to take a quick 60 seconds to play a channel trailer just because we got a bunch of people coming in.
Heck yeah.
Just to tell y'all about who we are and what we do here. And then we have a very special guest on today, y'all, who I'm going to pump up as much as I can because she can ask me to stop, but I don't want to because she's a bestie. So, y'all, we'll be back in 60 seconds. Raiders, welcome on in. Don't go anywhere. We'll be right back.
Welcome to Science Streams. If you are interested in all things science in a fun, wholesome environment, you are in the right place. SciAnts is a unique husband and wife team of Belinda and Lita, who hold their PhDs in molecular and systems biology from Dartmouth. What can you find here? The SciAnts team is dedicated to making science more accessible to our entire community. They believe that it is the responsibility of scientists to engage with the general public, and Twitch is one of their media doing this. By showcasing their own research, highlighting new discoveries, answering viewer questions, and sharing their passion with you. We do a variety of interactive science streams, including microscopy of ancient amber with insects, 3D printing, art, science news and deep dives, the occasional game, and more. If you've ever wanted to have a fun space to nerd out, now is your chance. We stream daily science content here on Twitch. Understanding not just what we know, but how and why we know it is the essence of scientific knowledge. Check out the About page for more information, and consider hitting the follow button to join our colony and our mission in science for all.
So again, Raiders, welcome on in. My name is Belinda. Our special guest today is Volcano Doc. Ginger Crush, that sounds amazing. What kind of puzzle was it? And thank you so very much for the raid and coming on in. We are chatting tonight with Volcano Doc. She's a real-life volcano scientist, geologist extraordinaire, and we're chatting about the intersection between, right now, geological sciences and biology. And I think one of my favorite answers of the night was the connection between what is called here this stromatolite, which is a 1.7 billion-year-old fossil that we have here. And it is from cyanobacteria. And I was asking Volcano Doc, we were watching a video, and I want to show all this part of the clip of the video, because here I am starting to question things, and Volcano Doc, puts me right in my spot. Because this
No,
in a good way, in the best of ways. This is an underwater stromatolite, and Volcano Doc was like, this is how we know how they could have existed back then. I was like, well, the biologist in me wonders, how is that? Because could have they evolved to have been onto different, soil layers, or like going from outside the water into water and vice versa? And then Volcano Doc hits me with, actually, the geological data, we can actually see where they were located in the geological strata, if they were in water or not, right? And so we can actually pull back the information, infer where they were, where the fossil is found, and actually look to them and their modern day ancestors, and they still exist today. So something that's 1.7 billion years old, we have fossil evidence of it from then and existing today. So it's again,
and the
like,
1.7 billion year old ones aren't even the old ones. Like, the oldest stromatolites are 3.4 billion years old. And those ones are literally the reason our atmosphere has oxygen and we can exist. So next time you wake up and you take a breath, think these little guys. These guys.
Yeah, and Dino Dave, yeah, these are in, Volcano Doc was telling us in Western Australia, too, that you can still see them today. And yeah, Dino Dave is taking a trip to be able, like, you're going all over, Dino Dave. Please take some photos. Earlier in the video,
dude, really.
There is this cross section here of what we can see, and it's really, Volcano Doc was telling us, like, cross section, this thing underwater, and that's what you're gonna see, which is really cool. Like, geology and biology coming together, like the formation of the world's atmosphere is at play. It's
When these are biosedimentary structures.
yeah. Oh yeah. And so it's I don't know. It's super cool to pull together the our two fields on this volcano doc. Like I didn't know how close we'd have a pull together, but it's super exciting that we have something like this tonight. Like this sample is.
It's really cool.
It is. So, y'all, I won this sample in Volcano Doc Streams. Yes, you can win billion-year-old fossils on Volcano Doc Streams simply by 10,000 channel points or by subscribing, and it's.
It's true. I grabbed the entire box off the shelf because I knew how valuable these samples were.
Which is still wild to me that there's just billion-year-old fossils on a shelf.
Yeah, just like right next to the rose quartz, and everybody goes for the rose quartz, and I'm like, why? There's 1.7 billion year old fossils here. Like, what is wrong with you people?
I don't know. Maybe it's not.
You know what? Everybody else's trash is my treasure, and I think that everybody else is different. Everybody's different for a reason, and that's why I think everybody has their thing that they know about and knows what's special.
Oh yeah,
lucky
absolutely.
us.
It's just so cool to me that you just saw it, right? And then you also have the value of what this is, and it's just really freaking cool. And that we were able to look at it under a microscope on a live stream on Twitch. Like, y'all, I know we look at 30 million year old amber with insects every Monday, but this is. The foundation.
But this is a 1.7 billion year old biosedimentary structure.
I know. I just totally got one upped. There's just so much for the insect. This is I didn't. I got when I won this, y'all. I looked at it and I was like, man, this is really cool. But I did not appreciate how truly remarkable it is. And I was actually as soon as we chatted about having this collab, I'm like, all right, I don't want to look at this thoroughly. I want to wait to have you on because I feel like the genuine reaction is more fun.
I'm really glad you did. I'm really glad you did.
Yeah.
I've been really waiting. I've been truthfully just so waiting for your community to get to see this and appreciate it because like you said, it was on a shelf. These people are going looking for rocks to make jewelry out of. They're ignoring it, and there's fossils that are the reason we exist on Earth next to them, and I want you guys to be able to see this. They don't belong on a shelf.
No, and just it's all maybe this isn't mind-blowing to anyone else, but the fact that they're around still today, right, shows how evolutionarily advantageous they were and how good of a job they actually did in surviving. So for those coming on in all the raids and from the front page, we were talking about geological time earlier in the stream, and what kind of eruption is fast and slow in my mind, and I'm 300 years that's a slow eruption. Volcano Doc's what do you mean? In the grand scheme of things, that's not even a blink. That's not even a breath. That's an eyelash existing, right? And so, but this. That's on the order of billions of years old, and Pandarius, they're still around today. Here's your example. Here's your modern day example right here off the coast of Australia. Right? These cyanobacteria are still around, showing just how resilient they are. And such a cool part is Volcano Doc's studying this in these oceans gives you an indicator of what these animals were like in the past. And I'm like, Volcano Doc, how do you know that? How do you know they were in water? And you know what? She's like, yeah, we can look at the sediment and the sediment deposits.
And it's not just about the animal, though. One of the cool things about this is that we know that oceans were around 3.4 billion years ago when these oldest stromatolites were, because that's this type of sediments they were found in. It tells us a lot about the condition of the Earth and how the Earth has changed throughout geologic time.
Could you tell us a little, Volcano Doc, about how one knows if it's an ocean sediment deposit? What do you have to do in order to get that information? How complicated is something like that?
The ripple marks are usually a good indicator.
Nice. And actually, I think we have ripple marks on this.
When I did so when you're in undergrad for geology, you do like field methods and field camp, et cetera, and I was super lucky and had the option to do baby field, which is like intro to field methods, over spring break in like a 2-week period, which, because I was like a single parent, was so convenient for me, because I could just be like, hey, I just have to be gone for 2 weeks and I'm sorry, it sucks, but then there's a whole class done, you know?
Wow.
So I was able to take field methods in the Bahamas. And there's like a research station on San Salvador Island, which is the island that Christopher Columbus landed on. And it was
Nice.
like such a cool experience. But one of the things that we did was go snorkeling and look at ripples on the ocean floor, and look at like rock, like bedrocks as it was being made at the beach interface, you know. And granted, it was limestone, but still. And you know, as viewers of paleontologizing will know, we in geology use this principle called the principle of uniformitarianism. The past is the key to the present. So we look at how things are being formed now, and if we find those environments in the past, we know that that's how these things formed in the past.
And then, like, presumably that's how they form now as well. So you can get both sides. So are these...
Well, no, we observe them now.
Yeah.
Like, if you have a big volcanic eruption and you get a giant ash deposit, you can look at another ash deposit in the rock and infer that, well, that probably formed from a giant volcanic eruption, because that's how they form today.
Yeah.
Does that make sense?
Absolutely. Are these the ripples, or am I totally misseeing where I'm...
Those are not the ripples. The ripples are going to be in the rock around it. You actually need to zoom out. Way out.
Volcano Doc, can I
This
say
is
a
the
secret?
cross section.
I can't even. I have to zoom like this then.
Yeah. So what you're seeing up close,
Mhm.
those individual layers, those are the microbial mats. Each one of
Okay.
those black layer, or like the darker layers in
Yeah.
the little mound, those are the microbial mats, right? And then like there's the sediment is the lighter bit.
Okay.
I mean, it's all like biosediment, but there's like different the little layers, those are each one microbial mat that build up these little mounds.
So like this dark region here.
Yeah, so
That's
like
a
that's
microbial mat.
that's gonna be like the top of a mound, and then if you move up, you can see like the mound-like structure in the center.
Yeah. Oh, you totally can. Look at that.
Yeah. See?
Yeah. Whoa. That's so cool. Nice.
That's how small these are, and they build up those big structures that you can see in the ocean that are people-sized.
Yeah.
Because they are literally bacteria. They're so tiny.
Yeah, I'm a little lost, obviously, on the sense of scale with on the YouTube video of just how big these structures actually are, right? Because there's just like nothing standing next to it. But these are...
I'd say definitely a couple feet for sure.
Okay, so definitely like a very sizable piece.
Maybe if okay, Jody says 3 feet. Cool.
Okay, nice.
That's what I thought. I just didn't know for sure.
Need those scale bars, you know. Hobbit size. There we go, Troy. Alright, so we pulled back the video a little bit, y'all. We're going to continue on. Please, if you have any questions from Volcano Doc, ask away. We'll be looking at the sample more underneath the microscope and just chatting science until she tells us, like, look, it's, you know, late, I need to eat or get to bed or what have you.
I have you booked out until 7:30, 8 at the very latest.
Okay, but we are grateful to have you, madame. Like, just honestly, truly.
I love talking shop. I really do. I love talking about volcanoes, and the problem is that I won't stop. So I'm neurodivergent. I have autism, and I have somehow stumbled into something that is my very special interest. So I will not shut up.
Listen,
which is why I have a schedule block.
That is totally fair, but it also highlights, like, like just that it is the right passion, right? That it's when you're that excited about it and you just continue, it's like, all right, I have found the right thing, which many people can, don't. And so
Exactly. Yeah, see, Deep Earthbound, same. And I mean, I'm so lucky. Like, I'm so lucky. Do I wish I could make buku bucks for it? Yes. Do I want some of that sweet climate change money I've been hearing so much about? Please lay it on me if it exists. It totally doesn't. But like, I'm really lucky, and it makes sense in my brain, and it's so exciting. They're so exciting and amazing and majestic, and I'm so lucky to have the privilege of, like, I don't want to even be saying be able to understand them, because I can't. Like, I don't understand them fully. Like, we don't know very much about them even, but like, I at least have the skills to kind of learn how to read them, and they're just amazing.
Yeah, it's that, like, the background training that goes into it is no small potatoes. And the fact that, I think being open about our differences also highlights to community members that you don't, like, a scientist doesn't fit in a particular mold. It's not a one cookie cutter shop kind of thing, which is, I feel like when you look at what the media depicts as a scientist, it's kind of what you see. It's an old white dude in a lab coat. And so it's really, I think, important and helpful to be, like, forthright about our differences and, like, what got us into the sciences and how we're still, we can be successful in the sciences even if we don't fit a particular mold.
Oh, yeah. And remind me to talk about that later. I would love to talk about that later, because if you're out there and you think that it's too late to go back to school or things have happened, you're fine. You got this. Don't worry. But South Rebel has a question, and I talked about this a little bit before. But yes, there are some volcanoes where climate change will affect them. Volcanoes that are heavily glaciated, especially like places like Iceland, maybe Antarctica, where there are glaciers on top of volcanoes that are active. As glaciers melt, you decrease the overloading pressure on the volcano. Will it trigger an eruption? Probably not, because the volcano has to already kind of be primed in order to erupt. But you're making it easier for the eruption to happen, because there's, like, less overburden for the magma to have to go through. So in that sense, actually, yes, there will be some increase in volcanic activity as climate change gets worse and temperatures increase. But that's why. It's because of the glacial melt. It's nothing to do with the inside of the Earth. The inside of the Earth is what drives volcanic eruptions, and there's no correlation between the inside of the Earth and climate change.
Yeah, so, like, South Rebel, I was asking Volcano Doc that earlier, because there's sometimes these videos that have misinformation spread that it's not the pressure of the ice sheets that are affecting, but it's also, like, temperature or something like that. Like, it's keeping them cold and it's keeping them at bay, or movies will show that, right?
No.
And it's not that at all, which is really cool to hear the professional volcanologist be like, no, it's this pressure that is, like, keeping everything in bay. And
it's lithostatic overburden. And the process is called, like, what is it, like, lithostatic rebound, glacial rebound. It's like how the Earth, the Earth flexes back up because it doesn't have the glaciers on it.
Nice, yeah, and it makes sense, which is really cool to hear. Coffee Rocks was wondering, Volcano Doc, are there less of these stromatolites around today due to, like, global warming or climate change that, in a way that we've affected the planet? Have we decreased the population of these cyanobacteria?
I have no idea. I'm sorry. I genuinely, like, I TA'd history of geology, which is, like, how the Earth changes and life on Earth evolves and stuff, like things that, like, paleontologizing could probably teach. And I study volcanoes. Right now, I'm, like, basically barely keeping the succulents alive. And in that class, my students got very good at drawing the samples that were there. I don't know how much they
JP
learned about the
underscore
samples that
sunset
were there, but they're
woodworking just
very,
subscribed for 19
very
months.
good at drawing them.
The one, the only, the
Therefore,
legendary
I am
JP
not
has
the one to
arrived.
answer your question. I'm sorry.
That's a very fair thing to say. JP Sunset Woodworking, thank you for the resub, my friend, for 19 months. The one, the only legendary JP has arrived. Woodcrafter extraordinaire JP, this piece of raw science is for you. Into the beaker you go, JP. We're nearing filling this up. If we fill it up, special raffle for a glow-in-the-dark DNA pin is on the menu. Thank you all very much for all that support. JP, welcome and thank you for the resub. We're on with Volcano Doc for anyone coming in. She is a real life volcanologist extraordinaire. Yes, she is trained in volcanoes, geology, earth science, and more. Please, please, please ask your questions. We're chatting about stromatolites right now. Is it easy? It is not, Dame Karen. I can do it afterwards, but live doing it is very difficult. I'm so sorry, madame, but I can look into that.
In the
for sure.
words of Calvin's father, it builds character.
Oh, this sounds. That's. Look, she said it. I didn't say it. She said it. Volcano Doc said that. What's in the jar is raw science, South Rebel. It is raw science, just like in the game Grounded. But if you actually want to know, it's rose quartz. Because it looks like what it looks like in the video game. And that's for every sub, resub, gift sub, as we're going towards this goal of that partner plus. Yeah, absolutely. Best thing for succulents is to keep them dust free by cleaning them, and if you can, water the soil directly, but don't water over them. Sparky Pugwash says.
Oh, yeah, no, I'm only good at them, Sparky, because you can forget about them. There's just a lot of variables, and I'm just very not great at things that are alive. I have no idea how my child survived, let alone, like, animals and plants and things. I don't know how I survived. This is why I'm good at rocks.
But Volcano Doc, the kiddo and all the pets, like, clearly you're good. You're good at that. But the plants, I get it. You know, they're different animals.
Valent, listen to me. One time, when I was a kid, I was sitting on I was at my grandma's house watching TV, and my grandma had, like, that none of the doors were, like, closed. It was just, like, the open doorways, you know what I mean? Like,
Yep.
between the rooms.
Yeah.
Just, like, the door frame, but no door. So you could, like, walk around the house and never open a door in a circle. So my little brother was sitting on the floor. He had broken his ankle. And he was watching TV, and he sits out. He's got his foot out like this. It's in a cast. And me, I was like, I don't know, like 8, 10. I don't know. I genuinely don't remember how old I was. But I was running around in a circle like a moron, and I tripped over my brother's broken ankle in a cast, and I broke my own ankle.
Oh no. Oh no. Did your brother re-injure himself, or was he fine?
I don't remember.
Okay.
I imagine he was fine.
Okay.
Oh no, it's absolutely objectively hilarious. I'm just saying, like, that's what I don't know how I've survived. Living things are not my expertise. I am good with rocks.
Fair enough, madame. Fair enough. Important question, who day? Indeed, who day, known Unk. Welcome the heck in. I am a very sad little Bengals fan, and it's fine. We're just, you know what? We're not... I go into every game assuming we're going to lose. Only once did I have hope, and that was in the Super Bowl, and they lost. So this is why I must never have hope when it comes to that. It's very true. Sharpest blade Volcano Doc should ever have to deal with
is kyanite. Kyanite is a mineral. It's really cool. I've got some, but
what
I
is
digress. Let's talk about stromatolites.
Fair. Let's continue the video. Y'all, we have a fossil here we're going to be looking at under the microscope. I have it here in my hand. Known Unk Houday, welcome the heck in. This is 1.7 billion years old. For some reason, I'm just holding it in my hand like it's...
With a B.
Is it okay to hold with my hand?
Yeah, it's fine.
Okay. I'm getting worried. I'm like, are the oils in my hand gonna break it down and just destroy it or something? And you're just like,
I mean, like, not on the time scales that you would care about.
okay, fair enough. Fair enough. So this is these are your modern day examples here. This is a lot of members in chat have actually correctly identified in Western Australia. We have these still around today, so they have survived really well. Let's learn a little bit more about them.
Mounds form in shallow water. The inside of the mound is rock and sediment, but its exterior surface is covered by thin layers of microorganisms called microbial mats or microbial films. These mats grow and develop on the surfaces of stromatolites and cause the mounds to form and develop over time. Although the stromatolites themselves are solid rock and sediment, the mats have the consistency of a gooey mucus. This mucus is due to the presence of an extracellular matrix secreted by the microorganisms.
And Dame Karen, we had, just because you say ooh, we had stopped on that particular part earlier because there are modern day bacteria that release the same biofilm, and a lot of labs are studying the biofilm because it's really hard to break apart. It is a protective barrier for bacteria that's been around for, well, billions of years. And for example, when you have, let's say, cystic fibrosis, what that means is your cilia in your lungs are unable to move mucus out because they're non-functional, and so you have colonization of bacteria throughout your lungs, right? And then it isn't the issue that you have bacteria in there, is that they form this biofilm, and it's just hard to break it down. And so it's really cool that this like very ancient ancestor did the exact same thing. And yeah, you're right, Dame Karen. Same thing with mucus, any kind of lung infection, anything that infects your breathing is really difficult to manage because of that reason. And so these biofilms, it's cool that it's like this protective mechanism of the bacteria was still around this long ago, and you can see it presumably in the fossil records as well, like remnants of it, like you were showing us, Volcano Doc.
Yeah, there's like, there are like microfossils and like ways that you can see fossilized bacteria. Sometimes it's actually just like isotopic ratios in the rock, which take that, it's really like cutting edge within the last like 5-10 years, and now we have like Edicarian fauna, which are animals that showed up before the Precambrian explosion, and there's just like teeny tiny fossils of like almost even single-celled organisms that I don't even know how these paleontologists recognize it as a fossil, but like, they don't understand what I do, I don't understand what they do. That's how it works. And they know what they're doing, but it's possible to see in the fossil record, yeah, these tiny little bacteria.
It's definitely difficult, I feel like, to see these things, right? But like, where it's the expertise of the scientist that lets them see what we're trying to identify, where it's like, same, like if I look at it under a microscope, I can tell you the brain regions of an insect like that, but the untrained eye, you're not going to see it. Or even Danny was telling us that he's out in the field and he's looking at, there's like a bone sticking out of the ground, and he can tell you by eye if that's worth digging up or not. I'm like, how on earth would you have that ability? And it's just the knowledge that you build up over time. And so it's really cool to see that as a metric for identifying these fossils too. And like, I'm sure a lot of stuff that you look at too, Volcano Doc, is due to your expertise and like looking at these for so long, which I think is really cool.
Yeah. I was chatting with the Mister a couple days ago. His expertise is in like asphalt and aggregates and concrete and cements and things like that. And apparently the volcano that erupted in Iceland, it erupted, the last one, well, not the last one, but the one that crossed the road No, it was the last one. It was on February 8th, and the lava flow crossed a road. February 8th. That's what, like, 18 days ago or something. I'm bad at math. I'm really terrible at math. Anyway, they've already paved a road over it.
Wow.
I'm not joking. Hang on. No. Guys, chat, listen. Chat, sit down. Chat. I'm not kidding. This is genuinely on the, like, Iceland Civil Defense page. They say that this road is open. However, caution. You must obey the speed limits when you're traveling on this new road. Be careful, because over the new lava flow there may be some sharp turns. However, do not stop, because the road and the outside may be too hot, and it may be unsafe.
And yet the road is open.
And so, like, I'm wondering, but, like, how do you make an asphalt that can, like, just be over hot lava? That if it's, like, so hot, they're like, don't stop when you're driving. How is an asphalt road existing, you know? And so I'm thinking, but, like, and so both of us are thinking of this, like, perspective of, like, what chemistry requirements have to exist for the asphalt and the lava. And it was just a really fun conversation, truthfully.
No, that is super, super cool. And I just, like you were saying...
I know, it's wild, right, chat?
Like, so if you stop, like, your rubber will start presumably burning, right? Like, if you're just hanging there, your tires will melt
I don't know what. I'm presuming, but, like, it just said, you know, do not stop because it is too hot and not safe. Which I'm like, why would you maybe, like... No, but I feel like at that point it might be worth making a different road, Charlie. Wee little bit. And that's the thing, Sparky, is I'm wondering, you know, you have to have a special asphalt mix for that, and there's all sorts of different considerations. You have to think about how are you going to handle, like, -20 at the surface versus, like, 600 C? I don't know. I was trying to do the math to see, like, what the surface temperature of the lava flow would be, but then I was tired and I already have too much stuff to do.
I feel you on that. Guys, the fancy shout out for Volcano Doc is in the chat right now. If that heart button for you is not clicked, you click that right now. Blow up her follow feed. I would like her computer to crash from so many follows. Professional volcanologist.
Oh, it's right on the computer. But yeah, like, that's the thing. It's really hot.
It's a super cool, although alarming, feature to be on the website. I would love to see videos because you know there's going to be someone who stopped.
Yes, Judy, it would be Mayfic. It is basalt. But yeah, yeah.
This is so freaking cool.
Yeah.
And so, question from Noah. So it isn't too hot to have a heavy object on it, but it's too hot if you sat there for a while, like a motorcycle. So if I park my bike for a few seconds, no problem, but leave it for a few hours, the kickstand will be sunk into the asphalt.
I have no idea. I mean, I feel like it shouldn't be a thing. I feel like you just shouldn't.
Yeah.
But I also read, and I still have to verify this, I've heard rumors of tourists being allowed near the newer lava flows by the Blue Lagoon. I do still need to vet this, but the photos appear genuine. In which case, yay, capitalism!
Is it dangerous?
I am not an expert in how lava flows move.
Okay. But it could be where it's a rapid movement that could put you in danger.
However,
Okay.
based on the volume of magma that's accumulated, it's not unexpected for another eruption in Iceland to happen within the next week. I would absolutely expect that.
Okay, so it's not necessarily like the stagger, like the flow that's just there they'd be looking at, but the possibility of there being another eruption, that could be the
Correct.
dangerous effect.
Correct.
And would we know if it's one of those slow eruptions or one of like the big boom eruptions? Is there a way to?
It would be a passive eruption, very similar to other, the Iceland eruptions we've been seeing over the past couple years on the peninsula. But the last one we had 30 minutes notice.
Oh wow, okay. So if you have a group of tourists out there,
virtually no notice.
Yeah, that's
and that's
not gonna
because you have a sustained magma pathway. You get notice from earthquakes, and earthquakes are the signals that are made when magma is breaking through rock. When you have a sustained magma pathway already established, you don't have any rock to break. So you can just have the magma moving, and at this point, we just maybe not even get any notice.
Right, because like you said, there's no reason.
There's no rock to break. It's already ductile. It's already an established conduit.
Path of least resistance, right?
And there would be some pre-eruptive signals. Do I know what they are? No. But I know that from the thermal history, what we've seen, the timing of earthquakes before the eruption decreasing very much with each new eruption. I'd say 30 minutes at the most notice next time.
Are there a lot of detecting tools right now on site in Iceland so that if there is another eruption, we can gather the data?
Yes.
Kind of how we've been talking about. So, like, we're at least getting more and more information from all these events with all the sensors that are in place.
Yes, it's super, and especially like this is one of the things I like to point out that disasters are not natural, because the last couple years in Iceland, it didn't matter. People were going and visiting. It was great. Like, it's a huge boon to tourism. But like, if you put it underneath a town, put a volcano underneath a town, same volcano, whole different story. So it's very, very, very well monitored. I mean, the Icelandic government everybody is on this thing. People, like, I personally know scientists who have flown across the world to be there and bring instrumentation and done the measurements. And they're on top of this. It's, at this point, it's just like, even with the good instrumentation and monitoring, you have 30 minutes.
And actually, Known UK says, I would think that places with volcanoes have built-in seismographs all over the place. We've learned today, Known. That is in fact not... I thought that too. That is not the case. It turns out all the instrumentation that you need, like, there's multiple kinds of instruments to get you all the data to make quality forecasts. Look at that, I'm using the right words. Are not on the most sites. Which is kind of alarming that that's how these things work, is that you don't have all the readers there.
Yeah. Write your government representatives and tell them to fund earth science research, fund the Department of Interior and the USGS so that we can have the money to put the instruments on the volcanoes. That's genuinely part of it.
Yeah. And let's see, Dino Dave says, even if you had the warnings with the New Zealand, the volcanoes over there, it went badly.
Well, so Dinosaur Dave, I'm glad that you brought up Vakari Island, because that is a little bit different, and I would love to have the opportunity to clarify. So we can see when magma moves through rock, because that generates volcanic earthquakes. The Vakari Island disaster was not a true eruption. No new lava came out. Instead, it's what's called a phreatic explosion. And that's when groundwater heats up and flashes to steam. When that happens, there's a 700 times volume increase from liquid to gas. if that happens underneath the ground, you can imagine what comes next. And there's really not a good way to detect water movement. We can detect magma movement on seismometers, but we can't detect what the water is doing. So there was no precursor to the phreatic explosion. Whether or not tourists should have been there in the first place is an entirely different conversation. But in terms of the explosion itself, Vakari Island was the water turning to steam all of a sudden, and the ground completely exploded. And there is no forewarning to that we have the technology right now to detect. Again, like I said, whether or not the people should have been there is an entirely different discussion. But the whole like precursors, there are no precursors to that.
And as Jody Fish said, presumably there wasn't a geyser or something to vent, right?
Yeah, there's fumaroles and stuff, but in this case, it's when your water starts to boil on the pot, it happens very quickly, and this is the same thing.
And it's just not enough time to vent off. It's just like that's why there was that big force behind it.
Yeah, and I feel like that is a distinction that the Vakari Island documentary does not get correct, and it does it a disservice. It really does it a disservice, because we should be having the conversation about whether or not people should have been there in the first place, not whether or not it could have been forecasted or predicted. At least in my opinion.
Yeah. Make it 100%. Like, look, you're the expert, number one. Number two, it makes sense to me. Right? Based on, like, what we know about how chemistry works and how the geological strata work and what the instrumentation we have, it makes sense. And Jody Fish, Traboon, instead of the Tradoon, of course.
Was Krakatoa a true eruption? Yes, Huggin. Yes. And if you want to know about the modern day equivalent, you can look up the 2022 eruption of Hunga Tonga Hunga Apai. I wrote the first paper on it.
Also, hats off to your pronunciation.
Based off of research done live on Twitch stream. True story.
There have actually been discoveries, y'all, on Twitch that have contributed to science, right? It's huge. Like new species have been discovered, right? With Danny, dinosaur digging, we actually discovered a new species of ant with a live stream of that, and so has Volcano Doc, which is really remarkable. Is there a YouTube page we can link Volcano Doc?
Oh, thanks, Charlie. To that VOD, not yet. I still have it and I can upload it.
Okay.
But I still have another project that I would like to publish before I make it public, because I did have a concept, an idea, and that project has not been submitted for publication yet.
So eventually, y'all, it will be live. And a great tool to be like, hey, Volcano Doc for partner.
Hopefully.
Should we continue the video, Volcano Doc?
Yes. Sorry.
Are we closing in on your last 40 minutes?
Maybe. Let's continue the video, and I'm gonna pop off to the kitchen for a second, and I'll be okay.
Okay.
These microbial mats generally consist of cyanobacteria, filaments or chains of microscopic bacteria that do photosynthesis, converting sunlight, carbon dioxide, and water into oxygen and food. The mounds are created by microbial mats. When sediment is deposited on top of the microbial mats, they become buried and die. But in the process, the sediment grains stick to the gooey mucus, to the extracellular matrix. This helps to trap, bind, and cement the sediment particles to the mound. Over time, The microbial mat will recolonize the surface of the stromatolite and grow on top of the new sediment. Then, the process will repeat itself again and again. Sediment will be trapped, binded, and cemented by the microbial mats onto the surface of the mound.
It is, and Sparky, you'll see in a second on the fossil, you are seeing these patterns, and it's really cool that the patterns are from these like membranous layers, like the biofilm layers of, you know, the dirt and everything getting stuck into it, then fossilizing, and then there's repeated on top of it. So you can actually see then and learn about a lot of the biology of the animal by just looking at these individual like little banding patterns here.
The stromatolite will grow upward, layer by layer. This repetitive cycle of sedimentation.
And this is a cross section, y'all. Let's see, 349. Cross section of like this. So this is one that's actually alive today, where you still have the cyanobacteria growing, and then you have that cross section that looks like this, where again you're able to see the individual layers on there. Humbler John, pleased to sleep well. Know that you're amazing and you're breathtaking. Guys, if you're not following our friend Humbler John, also go follow him, 3D Printing Wizard Extraordinaire. Sleep well, Humbler John. 5 seconds. 5 seconds. Welcome back, Volcano Doc.
What did I miss?
Talking about how that biofilm layer is able to acquire a lot of that sediment, and then it's building on top of another, and then just looking at another one of the cross sections. And so I went back and forth to show off the differences. It's just really cool to see, like, I'm just geeking out on the biological side of things about like having that biofilm layer, because that's what we know a lot about biofilms today and their uses, and it's really cool to see it in the past in action as well.
I didn't know that like that was, so for me it's really cool to see this from like a geological perspective, because I didn't know that like that's what some cells use and that's like what's being researched, and it's like, oh yeah, this has been around for like billions of years. Like, but like I've put in chat, if it's not broke, don't fix it.
Yeah, and
it works for a reason.
I wish we can get at what we obviously can't, right? Because the samples, you know, become stone. But maybe by looking at the modern cyanobacteria of like what's the composition of the biofilm, because there's evidence in some bacteria that there's even like RNA molecules that are released to cause like RNA interference and turn off certain genes, like in a potential like immune response that's against it, right? So there's like all these things in the biofilm that are protective for the bacteria that, you know, we're just scratching the surface of. Who knows if the cyanobacteria have the same thing, but like it's cool to think about.
I mean, maybe that's something that is being studied. I have no idea. Like I genuinely don't know. It seems very reasonable to me. Like stromatolites are, I mean, it's no secret where they are now, and I'm sure that somebody has to be doing that research. It seems really obvious.
It does, but the context that I know it is like all in a disease context, and that's where like again like where the money goes versus just like the evolutionary context of it, which I feel like could inform disease context, but it's not always like where the money goes, Chad. That's like some of the fundamental hard issues, right, to be following up on.
Fair. Sparky, no, you cannot tell the age of them by their size. In order to tell the age of most fossils, especially ones that are like super like older than like 50 to 100,000 years or so, you have to date the rock around it. So in this case, these are found in shallow marine sediments. We would date minerals in the sediments using different dating techniques that you look at different concentrations of isotopes in the minerals, et cetera, et cetera. The geochronologists do their fancy voodoo. They have a line and they give you a date.
So enlightened, but do we have to buy them dinner?
It's not carbon dating. It's another dating method. It's along the same lines of carbon dating, but it's with isotopes that have much longer half-lives on like billions and millions of years. The half-life of carbon, I think, is like 12,560 years, I want to say.
I know the 12,000 number. You're much closer than I am.
Oh, yeah.
Yeah. I will believe the geologists very readily, Volcano Doc.
Dude, I'm a volcano scientist. I'm not a paleontologist.
Coffee Rocks is wondering if there's any way to tell the difference in between, like, what is the composition in terms of the microbes in this. There's no way of knowing, right? Like, we can look at the modern equivalent.
Probably not.
Yeah.
No, probably not.
There's no, like, the DNA is gone. You know, that's like gone. RNA super gone.
We saw, actually, if you look underneath the microscope at your sample, the algal mat part has been silicified. It's been replaced by quartz and like basically just agate.
Sorry, Volcano Doc, let me pull it back.
Yeah, so you've got like these little the sedimentary mound that they build up, and then you'll have I think that this is the algal mat. If you genuinely, if you're an expert in this, please correct me. But it's my understanding that this is like the outer covering of an algal mat, and then you have like more and more build up on top. But this has been replaced by quartz. It's agate.
Yeah, so there's nothing we can actually
biologically
nothing measure here.
Organic is left.
Yeah. And even, I guess, if you were to look at the modern ones that are off the coast of Australia, there's nothing to say that population dynamic might be the exact same as before. In the sense of, like, it's only, like, cyanobacteria, right? There could be other, like, different flavors of cyanobacteria species mixed in there in the past, or vice versa, right? Like, it's...
Yeah, I mean, the different species of cyanobacteria have likely changed over time. Definitely since the first ones, because the oldest ones were 3.4 billion years old. They were present when the ocean didn't have any free oxygen. So our atmosphere didn't have free oxygen, and they took essentially what was left, like what was present in the atmosphere, and turned it into oxygen. Like they used the opposite. I don't know. I actually don't know the name of the process, so please fill me in, Belen, if you do know what it is that makes the actual. Thank you, Jody. Chemoautotrophy. That word.
Thank you, Jody.
Thank you. Takes not oxygen stuff and makes oxygen stuff. But eventually, the stromatolites, the cyanobacteria that are in the ocean, they make so much oxygen that the ocean supersaturates with it, and the atmosphere becomes oxygenated. But these cyanobacteria, for them, oxygen is poisonous, so it kills them. And then we go to a no oxygen atmosphere. These are preserved in rocks called banded iron formations. So there's rocks called banded iron formations that record this kind of flip-flop in the ocean, where you go from like jasper and chert to where you don't have free oxygen in the atmosphere, to like hematite and rust, the red layers, where you do have free oxygen in the atmosphere.
That's really cool that you can track it.
Yeah, you can track the flip-flop of levels of oxygen in the atmosphere that form because of these kinds of bacteria. And then eventually we stop making those because we have enough free oxygen in the atmosphere that we've, gone past the tipping point. Now we have free oxygen, an oxygenated atmosphere. That I assume that species of cyanobacteria probably isn't any longer around, and then something new forms. I actually don't know. But I do know that, the 3.4 billion year old ones, they're the reason we can exist.
It's so freaking cool to be able to hold something like this and to have that level of information and detail, right? Something like that could exist, that let us exist as well. And Dino Dave got us an image real quick on the Oh, that's a beautiful example of the banding right
Yeah,
there.
they're gorgeous.
Yeah.
Gorgeous rocks.
That is beautiful. And it's super cool and it makes sense to think about when it's done. You're no longer flip-flopping, it's just the one color now. Totally makes sense. And it's neat again to see the intersection of geology and biology coming together, right? What the cyanobacteria are doing is reflected in the geological strata.
Yeah. And I really like that Danny brought up, just how underappreciated these stromatolites are. I think no disrespect to paleontologizing, but dinosaurs get a little too much love, I think. I think that there are a lot of organisms out there, even like invertebrates, maybe like bacterias and stuff, that are responsible for a whole lot of things today that don't get the love that they deserve.
It's because we need a powerful movie. Like the stromatolites coming back and taking over or something.
We'll have to have Martin Scorsese direct it, because that's the only way you can have a movie long enough to allow stromatolites to build up that will still make box office dollars.
That's fair. That is fair. He is still pretty box office safe, right?
For long movies, too.
Yeah. It's actually surprising. Although the new Dune apparently is super long and it's super well reviewed.
I'm a bad nerd.
You're not. You're the best of nerds. Thought it was Tommy Lee Jones' Volcano.
Fun fact, corn relish, actually. Tommy Lee Jones's Volcano is maybe my favorite disaster movie because it highlights an absolutely essential but 100% neglected person and character in this stuff, and that is the emergency manager for a city, right? Emergency management is like, that's the branch of the government that connects with scientists like me, that like actually are in charge of figuring out what the hazards are and what has to happen when there's an emergency. And Volcano is the only disaster movie that I know of that actually has that character as a role. So like, even though nothing else about that movie is accurate in any way, shape, or form, and it is absolutely ridiculous, for that factor alone, that's my favorite disaster movie.
How stressful must that position be?
Oh god, dude, I did a FEMA exercise and it was just role play. And I was having like heart palpitations, having to like make decisions. Genuinely. I don't know. Like, I just, yeah, you have to be stone and patience and calm for that. It's amazing. The people who are in emergency management, and every city has an emergency manager. So like, go give your emergency managers some love. Seriously. Like, tell them thank you. They're underappreciated. They are on top of it. They do a lot of hard work.
I guess not just underappreciated, but also unknown.
Yeah.
Like, I'm surprised. Like, I guess you're right. Like in the movies, all the disaster flicks I've seen, there's never someone in charge of initiating like disaster plans or
OEM, Office of Emergency Management.
I also, though, thought, as Corn Relish said, Octavius, thank you for the tier 1 gifts of the Calderas. Thank you very much. Octavius, hi. Welcome in, Octavius. Another piece of raw science added in, my friend, to the beaker. Octavius, how's it going? Thank you for that gift up to Calderius. Thank you, Octavius.
That's Calderas. Calderas.
Calderas. I blended
as
Octavius.
In the giant volcanic caldera.
Thank you, Octavius. How's it going, sir? Appreciate that gift sub. If that person in Hawaii becomes real famous, you'll know that sort. That is true. I also, though, thought, as Corn Relish said, I thought you meant like Tommy Lee Jones was the real character. I was like, oh my god, did he really do the Like,
No, but that was his character, if I recall correctly, right?
I haven't seen it, but I thought for a hot second it was like the real Tommy Lee Jones doing that. I'm like, well, what?
No.
He fought aliens. It's fine. It's fine. I changed pronounced in Moonrise Rabbit. I used to be I am Krakatoa.
Krakatoa.
I only know Krakatoa because of Finding Nemo.
It's misspelled. It's Krakatoa.
In Finding Nemo too.
Krakatoa.
Just when you
It's
think,
okay.
just when you think Finding
Dude,
Nemo.
I didn't know that until I was in grad school.
That's right. He did catch a fugitive. That is very true. That is very true.
And that's why we're here. We don't know. We learn when we make mistakes and we ask questions.
Absolutely. Yeah, that's the fun part about doing this too, is that you can impart the knowledge that you've gone through, right? I mean, grad school is not a joke. It's not just like, 2 years and you're done. It's a while. It's a while. Enemy, that is a terrifying emote. I mean, it's accurate, but it's also terrifying. If NMD is still here, NMD has some good feet emotes she can drop in chat from our friend Silly V. But you have more? Alright, enemy, terrify me. Oh, good God. Octavius, that's even worse. That one's dirty. Shall we continue the video? Okay, I love everyone.
Yeah.
Ew,
Yeah.
gross. Thank you, Octavius.
Sedimentation produces the layers and laminae of the stromatolite. It's a long process. Each lamina is thin, and they are slowly added by the trapping and binding of sediment by microbial mats. So it can take thousands of years for stromatolites to develop into large structures. One of the best places in the world to see stromatolites forming today is called Shark Bay, a protected World Heritage Site located in a lagoon on the western coast of Australia. Today, stromatolites are generally rare. Today, stromatolites are only found in shallow hypersaline lakes and lagoons like Shark Bay, where high salt levels deter animals from grazing and eating the microbial mats on the surfaces of the stromatolites. The water is generally so salty that you can't sink in it. The water is simply too dense. These salty conditions develop in response to high rates of evaporation and poor circulation.
Have you been to these locations, Volcano Doc?
I have not. But what you would expect to... So, I have not, and I have not personally examined the rocks. I've handled stromatolites, but not from Salt Bay. If they only form in very saline shallow, like lacustrine or marine deposits, which lacustrine is a fancy word for lake, marine is a fancy word for ocean. But then I would expect to see high salt levels in those rocks as well. And I do not know if that is seen in all of the deposits where stromatolites occur throughout geologic time. I can just say that that's what I would expect if this was the continued environment.
Gotcha. Nice. And Jody Fish was saying that the black too was due to the oxygen.
Yeah, that makes sense.
Yeah, which is I'm like, oh, that's really cool. Again, like everything coming together. Hi, Turgus. Thank you for the lick emote. Turgus knows we got the ear and the toes, but now we're back on the lake ones. We're good. We're totally good. And Harissa, sleep well. Thank you for hanging with us.
Good night, Harissa. Thank you so much.
The surrounding water. During Precambrian times, stromatolites were far more common. Animals had not yet evolved on Earth, so there was nothing there to consume the microbial mats. They could form in a variety of environments, not just hypersaline lakes and lagoons. That's why many sedimentary strata in the Precambrian contain stromatolitic structures.
Well, there we go. They don't even need to be in saline lakes all the time.
Wow, that's really, really cool.
Animal.
All right, let's take a look then under the scope, Volcano Doc. So we already kind of were touching on it. Y'all, this is a live look. This sample is 1.7 billion years old, and the one you're holding, is that from the same set? We can't hear you, Volcano Doc. Volcano Doc, we can't hear you.
Oh, thank you. I'm muted. I'm an idiot. I do this all the time. You can tell that I have a doctorate degree from an R1 research university because of my amazing ability to work microphone buttons and remotes.
Look, you joke, okay? But being a streamer means you have to be like your own TV crew, okay? Like lighting, audio, effects, all the things, okay? So we gotta be gentle on ourselves at this stage, all right? That is no joke.
I'm just saying. Hey, Lalo, hi. How are you?
Lalo,
What's
thank
up,
you for
dude?
the follow. Welcome in. You know, Rox.
Lalo is a homeboy.
Oh yeah. Is it
Yeah,
OG,
Lalo is a homeboy.
an OG member of the Volcano Doc. What is the crew called, Volcano Doc? I know
The
it's the
Lava Lab.
I knew the Discord was the Lava Lab, but I didn't know if there was some kind of extra, like an inner chamber of a volcano is like the inner core of the.
No, we pretty much just call it a magma reservoir.
Nice. Okay, fair enough. The magmalites.
The microlights. That sounds lame though.
I don't know. I think it sounds cool. It is, Corn Relish. It's very hot. It's actually the hottest stream on Twitch.
It's a true story. But yeah, so this is what it looks like if you were to like cut it and polish it. So here you can see like the different mounds. So each one of these like little mounds, the little black line, that's what's showing up above Bolin's head. It's been replaced by quartz. It's basically agate. And so one of these little mounds, you're seeing like one of these lines above Bolin. And each one of these is one of those like tiny microbial mats that would make up one of those big, huge stromatolites that's in Shark Bay.
So one of these lines here, like that black line or the one above my head, was the thing that was filled with this bacterial film.
That's my understanding.
Okay,
that is my understanding.
They were
yes.
building the dirt on top of them, so like the ridges further up that we're seeing are also then like as a result of that, and then you'll have the next layer, and then the next layer, and the same, because like in the video it's saying they're on top.
Correct.
Gotcha.
Yeah.
Did you polish this one?
No, this one was this was on the shelf. I don't understand. It was like 50 cents a pound, dude. 1.7 billion year old fossils were just like on a back shelf for 50 cents a pound, and nobody was buying them. It just like blows my mind. I had to buy all of it. Not all of it, but like almost all of it. I had to leave some.
I mean, you don't want
it wasn't FOP, Irish. I love that you know FOP though.
What is FOP? Impeachment
FOP
Hunt!
is Friends of the Pleistocene, and Friends of the Pleistocene is this like very amazing group. You've returned from FOP. I never went on an FOP trip because I like had a daughter. Like I have a daughter, and I wasn't like able to get a sitter. But my now husband did FOP, and dude, the stories are great. The stories are not fit for SciAnts streams. Because the stories are a family trip. Oh. Well, FOP has gotten much more wholesome since we were in grad school.
No. I think that's two different people. So, right, Irish can know what you about the FOP.
Oh, sorry. Oh yeah, I just saw a family trip. Oh yeah, Irish. Yeah. No. So FOP, very geologists in the field shenaniganry.
Ah, gotcha. No, our friend Fishman is actually a service member in the Navy, and he just got back from a family trip as well. I'm glad to hear it was good, Fishman. He was raising money for Step Up, an organization for veterans. He was doing a Lego build stream, and you could get him to cover his body in temporary tattoos.
Cool.
And like he couldn't progress on the Lego until like he was making the donations up, and so we were getting excited to support our friend Fishman on that. And thank you, Travel the World, for the stretch. I'm cracking away on it.
Yeah, if you guys want to know a good time, go on a geology field trip. If you're in college and if you've like wondered about taking that class, dude, do it. Just try it. You never know. Plus, it's fun.
It's neat that there are these courses available in college too to expand. Like, would you say that it's important? Did you do like I guess okay? Did you know that you wanted to go into geology? Or was it just a course that you took and you just happened to fall in love with it, or something totally different?
No, I didn't. We should talk about. Oh, you're from Humboldt State. Oh, dude. My last manager was from Humboldt State. I did my master's at Fresno State. Nice. Sorry, we're doing a little like Cal State system geology. Little. Hey, what's up? Anyway, sorry. No, I have a very unique background. I have, as you know, as people from my community know, I am a very non-traditional college student. I, in fact, am one of a very small. It's a Cal Poly? Are you serious? Sorry. Wait, what? We should discuss like Barbara Streisand, like discuss amongst ourselves. We should discuss this. Okay, I digress. Okay, so I have a very non-traditional background, and I didn't graduate high school. I actually dropped out of high school because I got pregnant, and I dropped out because I needed to work full time, and I had my daughter, and I like got my GED, and then I like worked my way up through my associates through community college, and then I like moved out, or I did my bachelor's at the school like in the city, and then went to California to Fresno State to do my master's, and then to Santa Barbara to do my PhD at UC Santa Barbara, and in there met my husband, eventually got married, and et cetera, et cetera. But for many years, I was a single parent and a college student and a grad student, and it was not easy. But I share my story because I know that there are people out there that might find themselves in a similar situation and maybe don't want to feel like a statistic. And you can totally, I will admit, I got very, very lucky in that, it's a lot of hard work, but there's also quite a bit of luck involved. Right place at the right time. I found an advisor who would work with me having a kid. I on days my daughter had a snow day, my mineralogy professor was really awesome and let me bring her to class, as long as she didn't make a disruption, but she was really, really well behaved. And like by sharing my story, I hope that maybe there's somebody out there who maybe you think that, oh, it's too late or it's too much, and it's a lot of work, it's a lot of stress, but you can do it. You can do it.
And we really appreciate you sharing that story. Y'all, I tell Volcano Dog this all the time. She shared this at the TwitchCon panel, and I'm pretty sure blew everyone out of the water with the story, because it is really inspirational. It does mean that it's never too late, and you're not limited by, age, kid, any of that. I mean, Volcano.
Exactly. See, Sloppy in chat. They're taking their first college class at 28, right? And that's awesome.
Yeah, absolutely. It's never too old to get that You're never too old to get that education. But again, like, with a kiddo in grad school, volcano doctor, that's huge, man. Like, it was hard enough without a child, and just like going.
I didn't sleep. I was very young and I didn't sleep. If I had to do it now, I don't think I could do it. But I was very young and I didn't sleep.
It's really, really inspirational. Like, I'm not just saying that when you blew us all, like, everyone out of the water, is like, that was the highlight comment of that panel. And like the most
Thank you. I mean, I wasn't trying.
No, I know. No.
I want people to just know that, like, you're not destined to be what other people say you are.
I know, and I know that's not how you meant it, but I just mean, like, because it was so inspirational, because it was like, yes, anyone can do this. Like, because I think there are plenty of scientists who are out in the media who are very insular, who don't let people in, and I think that's one of the reasons why we have issues with, like, trust in science, especially COVID science. Like, I know my old advisor was like, the public is stupid, why would you ever engage, right? And that attitude does seep through. And so when you have someone with the degree, like, you've done all the training, you are the expert, and you're like, I didn't just have it spoon-fed to me. I worked my butt off through all these trials and tribulations, and look at me, I got this. Like, that's really inspiring.
Well, I not by myself. I mean, it took a lot of help. I had a lot of support. I mean, my now husband has been an amazing support system. Like, he's phenomenal. My advisors through grad school, like, and my friends through grad school have just been phenomenal support systems, and I could not have done it without them. Like, like they say, it takes a village. It totally does, and I know that that's something that you and Lita, I'm sure, are experiencing.
Yeah. I mean, but, it's just with the added pressure of grad. I just think back, like, if grad school, like, in the geological sciences.
Well, you guys are scientists. You still have that pressure. You still gotta see. Look at her. Look at how cute she is.
Well, but just like the pressure of, like, in a graduate program. I don't know how in geology if it's the same cutthroat, like, publish or perish mentality to, like, get the paper to get the next position, and if you're, like, not working hard enough, then you, like, you will throttle your career kind of deal, right? It's like, grad school is not a luxurious life.
It is like that. Yeah.
And so the added pressure with, like, raising it's just, Madame, you're Wonder Woman. That's all I gotta say.
Thank you, but also likewise.
But and thank you for being
to both
so open.
You and Lita. You both are amazing scientists and wonderful science communicators and wonderful inspirations.
Right back.
And I know everybody in chat agrees with me.
Everyone in chat agrees with me about you.
Or they're getting banned.
Or they're getting mods.
Mods.
I think that's
I'm not wrong.
Hugin's way of saying no. The Cornell's just hiding. No, Madame, you don't dare hide. No, but seriously, thank you for being so open and sharing those stories. Like, you never know who that's gonna touch, right? And, like, inspired to be the next. Like, Lita's also open with, like, her neurodivergence, and, like, we've talked about openly about the dyslexia and, like, how it's, like, overcoming those barriers as well. And there's just a lot of different factors, and it's, you're just knowing that you're not alone, and it's not just you going through it. You never know who's gonna inspire the next, and it's really cool.
And something else is that, like, it's coming to be more recognized within the last couple years, especially since the pandemic. But, like, I think it's like 1 in 5 or 1 in 6 college students are parents. That is not a small number. It's not a small number at all. And I think as scientists, and hopefully I can have a tenure track position one day. I don't know if that is your goal, or what position, hopefully we can both be in a position to mentor future scientists one day. But like, I think that it's really, really important to be able to show people that there's more than one type of thing that can fit a scientist, and that, yes, things are harder when you have a family that you have to consider, and you can't spend 100% of your time doing things, but you learn to balance, and you learn to sacrifice some things like a social life. And I'm just saying. But like, luckily, I really like volcanoes, and I've got a lot of really cool friends that also study volcanoes. So like, and I've got a lot of really cool friends from Twitch and that are scientists and not scientists, and I have a lot of really amazing people in my life. So I'm good.
It's a lot of sacrifice, but at the end of the day, the hope is that it's worth it on some level, right? And I know you touch many people's lives. I know on Twitch, right? About like just what you can do with volcanoes and the science band, but also making a community. Like the Lava Lab, I'm a big fan of the pet channel, the Lava Lab, obviously. I just always love seeing all the pets. But there's like science being disseminated there and discussions, and it's like a safe space to learn.
And it's not just me, though. It's not just me. I gotta give mad props to my community. Like, we wouldn't be where we are without our communities. For real.
Yeah, absolutely. And it's just like cultivating a place for learning is, I think, or a successful place of learning is a commentary on you, Volcano Doc, and like what a great job that you've done in building it, because that's not easy, right? Like it's.
Well, thank you, but
like,
likewise.
Well, it's like anyone can go live, but like building something successful is dependent on the group of people that you're building it with, and you can imagine if you don't have that support system behind what you're building, it's not going to work. And so it's.
That's true.
Yeah, it's hard.
That's very, very true.
So Volcano Doc, it's 2 minutes
Yes.
until you're out. I want to make sure that we get all the plugs in for everything that you want to talk about, or if we have a little bit more time, then do more volcano stuff. I want to be respectful of you and your
I can do a little bit more time. I can do a little bit more time.
Okay, no pressure, please. Like,
No, Mr. Volcano made oh my gosh, he made the most amazing Italian soup from scratch. And it's like heavy on the noodles and meatballs with like fresh spinach and carrot. It was so amazing, and the broth was just like delectable on my tongue. It was so tasty. So I'll give you a little bit longer, but I do have that waiting for me, so I'm very excited. It is super delicious, Sparky. Oh my gosh, it was so good.
Is Mr. Volcano Italian?
No, he's
Okay.
just a phenomenal cook.
Nice. That's always a great partner to have, right? Look, food is definitely the way to my heart.
Our love language is food, so we both have to. We have.
Ma'am, at the end of the day, we just gotta be happy. My vice is bread. And I just love bread, and my dad's always like, "You knock that off." I'm like, "Cut that out. I don't want to knock it off." All right. So I guess before we lose you for the evening, what I do want to set aside time to promote you and talk about every place where we can find you. But beforehand, maybe if we can just take a look, are there any parts of this fossil that you feel like we should definitely take a look at that would be really cool to see under the microscope?
No, it's like genuinely like that's just it. It's more of that this is a 1.7 billion year old fossil that is a biosedimentary structure, and this is the organism that is the reason that we have an atmosphere that can support life. It might not be much to look at. But
I think it's incredible at the amount of
amazing fossil and an amazing organism.
The amount of information that we've just gotten out from it, just chatting about it today, about like the various ridges, what they mean, like what these deposits are, how those have like been communicated to us. Like, it's really remarkable of all the things that we get from this.
Yeah. Yeah. So Sparky asked if it was the time when the ocean turned to algae soup. No, this is 1.7 billion years old. You're thinking about the Great Oxygenation Event. We did talk about that earlier, and that's the 3.3 billion year old stromatolites. These are from Wyoming. I'm going to put a link in chat that has, yeah, you're welcome. This has info on these stromatolites. This is from the Snowy Range stromatolites. So these were like shallow marine sediments when the mountains formed during the Laramide orogeny, when like the Rocky Mountains formed. Or not the Rocky Mountains, sorry. It's the chain after the Rocky Mountains. I don't know if it's the Laramie chain or not. I don't actually know the name for the chain. But when they formed, when they uplifted, these got smushed up and brought up towards the surface, and then there's a lot of fancy colored maps. Basically, these got brought towards the surface, and yes, they're there.
Nice. Corn Relish's stromatolites is almost as fun to say as lucibuffogens, which are
how do you say that?
Lucibuffogen.
Lucibuffogen.
They're the molecules deposited by a male firefly to the female. That's like, it's a nuptial gift that imparts her with like increased immunity and protection against pathogens. So, and there's a species of firefly.
Nuptial gift is a very polite way of putting it.
Well, okay. There are species of firefly that don't have it. So then there's females called the femme fatale that lure in males of different species by mimicking their pulsing calls. And then when the males come in, they eat them and steal their lucibuffogens.
I know, but now I'm just going to say nuptial gift.
Well, look, Volcano Doc, we're family friendly. We're creative.
You have to be. It's a very family friendly stream. It's a great way to express that.
We do have kids. Like, I've had people say that, like, I put you on the TV and like my kiddo's watching the microscopy on Mondays, and
yeah, I tell people I tell like kids to come watch you and Danny.
I think that's really cool. There's like families who are like 9.5 is always like, I'm comfortable leaving you on because I know it's going to be a safe space for the kids.
Exactly. Like, by the way, if I do have a PG-13 stream, which if you're in chat, I do want to just say I do have kind of a PG-13 stream because I tend to be a little bit more adult-ish when I am being more frank, and I am very much been watching myself for this collaboration. But I do just want to say that in case kids are watching and you're interested in watching me, I am fine with that, and please just let me know and I will do my very best. But I am a PG-13 person.
And an absolute legend.
But a load of fun.
Oh yeah, absolutely. It's always a fun time. I like lately, Volcano Doc, when I've had you on, I've been playing video games. I'm like playing Star Wars and just like listening to you tell me about Volcano. It's a blast. I'm just like, yeah, this is great. It's like once I get on Mustafar, it's even better. I'm like nerd out with Star Wars with you. It's awesome. Tommy was wondering if he was wondering about Snowball Earth, and he could ask you a question about it.
Ooh. Yeah, I can try to answer.
So Tommy, feel free to post it.
I can try to answer. I actually do know a gal whose expertise is in Snowball Earth, and I would love to have her come on. It just kind of depends on her schedule. Corn Relish, Snowball Earth is a time during Earth's history when it was literally covered almost all the way by ice.
So Tommy would just like a summary on it. Briefly read about it, and if you just could give us a little bit of a background.
Yeah, so essentially it's when glaciers covered the entire Earth. It likely it's hypothesized to have happened before the Cambrian explosion, so before there was diverse multicellular life forms. And pretty much it's kind of like a runaway feedback effect. So where the term I'm going to introduce a word here, and in a minute you'll see how it connects. There's a term called albedo, which refers to the reflectivity of something. When something has a high albedo, it is very reflective. When it has a low albedo, it is not very reflective. So if you've ever like gone outside, and there's a lot of snow at night, you know how it's like, oh, it's super light out. It's like there's lights everywhere. That's because white things have a high albedo. Yeah, exactly, Tommy. White has a high albedo, like snow and ice have a very high albedo. They reflect light very easily. So when you have a lot of glaciers on Earth, and this does kind of tie into climate change. So just kind of like think about this while I'm saying this. If you have a lot of glaciers, a lot of ice cover and snow cover, one, your global temperature is going to be cold. Two, you're going to have a higher albedo because you have a large percentage of the planet that is covered with ice and snow. That high albedo means light will reflect away instead of being absorbed by our planet. Heat from the sun is what keeps the Earth warm, right? The greenhouse effect is kind of a good thing. Without the greenhouse effect, we wouldn't be able to sustain life on Earth. Trapping those gases helps the Earth be a habitable temperature. Without those gases, the Earth gets too cold for life, right? So we need the greenhouse effect. We just need it at the right level. Right now, it's going way out of the way, so we need to bring it back down. But without it, we can't have any life. So at this point, like, we have some ice and some glaciers on Earth, but because the albedo is increasing, things get colder, and that lowers the temperature on Earth, which makes it more conducive to having ice and snow at lower latitudes, which means that the albedo of the planet is higher, which reflects more light, which lowers the global temperature, which means that you can have snow and ice at lower latitudes, which increases the albedo of the planet, which reflects more light, which lowers the global temperature, which means you can have ice and glaciers at lower latitudes. And you guys see where I'm going here, right? So eventually, the premise of Snowball Earth is that the whole planet is just covered and locked in ice. And I mean, there's probably some bits that aren't actually glaciated, but we have glaciers at the equator. Like there's geologic evidence for glaciers at the equator during this time period. There's no question about it. It happened. And so then the question becomes, how do you get out of it? Well, you have to have large periods of intense volcanism to break up your continents and introduce a bunch of sulfur dioxide into the atmosphere, and not sulfur dioxide. That's the wrong thing. Carbon dioxide and methane and other greenhouse gases, and just like really overload the atmosphere to lower the albedo and increase the global temperature and then melt the glaciers. Yeah, see, Irish, it's just a bunch of it's just positive feedback effects one way to global glaciation, and then back the other way to no glaciers, and then back this way to global glaciation. It's hypothesized there's a couple different global glaciations. There's like, I think 3 of them. There's 3 or 4 different proposed snowball Earth events throughout Earth's history. And it just kind of goes like back and forth for a while.
Oh, that's really cool.
Yeah, it really is.
I like how you were explaining the feedback. It made really accessible sense of, like, the lower latitude and again and again and again and again. And so then all of a sudden, like, the nomenclature of it also, like, why it would be called Snowball Earth, that makes sense. That's really cool.
You're so very welcome, Tommy. But yeah, like, I feel like it's necessary to explain it that way because when I hear the term positive feedback, it doesn't really like click in my brain,
Mm-hmm.
And I like to like, even though I over-explain things sometimes, I feel like, it's still worth it.
I thought that was a great explanation.
Have we not altered the loops beyond natural levels? With climate change, yes, we have. Yes, we have. So it's just going to be like, are we going to be around when it swings back the other way? Probably not. we'll probably all be extinct by then. Some other species will be around. Earth will survive. We won't. I'm very cavalier when I say that, because I'm very, very clear.
Raiders, welcome in. We got Instant Banana in his house. Banana Raid peeling in. Prepare for potassium intake. Instant Banana, welcome the heck in, Raiders. How was the stream? How was Baldur's Gate 3? We got Instant Banana, we got Schlepp, we got Ms. Viz. Welcome the heck in, y'all. How was the stream? Tell us all the things. 3D Demon Reaming, welcome on in. Raiders, my name is Balint. I'm 1/3 of SciAnts streams. The other 2/3 are my lovely wife Lita and our daughter baby Alona. We're research scientists. We do live science here on Twitch 7 days a week, and today we're joined by Professor of Volcanology, Volcano Doc, who's got a poop emoji with her.
I sure do.
Is there a story to the poop emoji?
Not related to volcanoes.
Okay. I was like, wait a minute. Like, thank you for that follow, 3D. And God of Brownies, my God, I love that name. Welcome on in. Y'all, how was Baldur's Gate 3? Was there romancing of the bear? That's the only thing I know about that game, is you can romance a bear that will turn into a people. It was great, fun time. It was my first night as a full-time content creator. Well, congratulations. That's huge. Big congrats. That's excellent, Instant Banana. Anything that you would like to share, please drop it in the chat. Any links, anything at all. Big congratulations. That is a huge step and a terrifying step to take. And so our hats off to you for that. That's, I think, definitely my dream, too, to one day be on that front. So big congrats. If there's anything at all that we can do to support you in that journey, please let us know. Feel free to post anything and everything you wanted to chat. You can romance a buff Squid Man, too. Alright, well, I'm more into this. I like the squid person. It sounds like cooler than the bear person. I only know from our friend Nerdy Senpai, she was romancing the bear, and that's where I know that this is a thing, because it was very common on that front. But yeah, Raiders, we are joined today by Volcano Doc. She is a science creator here on Twitch, specializing in volcanoes and geology. Her name is in the channel description today. I highly encourage y'all to go follow her. She is unofficially, by my being willed, on a partner push. And I would like to blow up her follow alerts tonight. So if y'all wouldn't mind hitting follow on our friend Volcano Doc, we're going to give her a fancy shout out when she's going to be... We're rounding out our chat with her. She has to go have dinner. I can already smell her dinner from here. It's delicious smelling soup. And I want to make sure that we get her, to her dinner on time. We're going to give her the fancy shout out then. But if you don't want to wait for then, and of course you don't want to wait for then, you're going to click on her name at the bottom of the episode description today. It's in two places. And if there's a little heart, if you hover over her name that's empty, don't break my heart. Please hit that heart button on the lovely Volcano Doc. And Jody Fish, sleep well, Jody Fish. Thank you for hanging with us. I will let everyone know that at 7:50, we're doing an e-girl stream for a full 8 hours. Everything ready to go, and we're getting closer and closer to that goal. Well, there y'all go. There you go. It's a banana. Thank you for that. It's a banana. If there's any link tree or anything at all you want to share, feel free to drop it into the chat as well. With that, Volcano Doc, is there anything that you would like to, promote, upcoming events, stream events? I know there's going to be a stream, Coffee with Scientists, that you've started to do on Saturday mornings. Anything at all, madame, the floor is yours of promoting anything and everything.
Thanks. So I'm doing Coffee with a Scientist, which is kind of like this, but we're going to talk more about, the guests' research, their background. This Saturday on my channel, we're going to do 8:30 a.m. I know it's a little early, but that's why it's called Coffee with a Scientist. You can be in your PJs, just have your coffee.
But 8:30
we'll
Pacific.
Be the scientists. We'll have the coffee. That's all. PJs are fine. I might be in my PJs. And then on March 30th, Balint will be up bright and early. You guys believe he's gonna get up out of bed and be on stream before noon Eastern? I'm just kidding. I know that you're up early.
I'm already up at that time, but
I know.
But yeah, Pacific Standard 8:30, y'all.
Yeah, 8:30 Pacific, 11:30 Eastern. Belint will be on Saturday, March 30th. We're going to have Fred Hutch do a charity stream for leukemia, for acute lymphomatic leukemia, and that is because my best friend's son has been diagnosed with that. He's pretty much like almost done. I think he's got another like 6 months left in his chemo, and then he's good.
Awesome.
Which is amazing. Yeah, no, it's amazing.
When you said he's done, I held my breath for a hot second. But because it is like, it's a terrifying thing, and so it's the Fred Hutch. We did a charity stream for them too. They're great, like the premier cancer center.
Yeah. So I think it'll be really, really good to. I've talked to my best friends, and she already has like a couple questions to ask. Really, she's actually really excited about it. One of the things that she's interested in knowing is, like, her son has to go through chemo for like 2.5 years. You know, it's not easy. Yeah, it's a long time. But I guess if you're an adult, you just go through really intense chemo for a very short period of time.
That's what I had always thought. It was like a shorter one, but that's pretty intense. For how long?
I guess with I don't know if it's with kids or what. And so her question is like, well, is that because there might be, you know, it might affect his growth? Is it because he's young, you know, that he has to do this for literally years instead of doing it for just a month or two?
Yeah. Wow.
And so that's something that she's curious about. It's so much harder on kids. Like, it's so much harder. I mean, not only are they just kids, but they have to go through something for years that adults only have to deal with for a month.
So that'll be coming up. When is that stream gonna be, Volcano Doc?
So that's this Saturday. We're gonna be talking with Dr. Kelsey Woodruff, who does research childhood leukemia, and not only talk about like not just that disease, but just like how this kind of research happens in general. You guys can ask questions. Again, not just about that type of research, but about her background, you know, cancer research, viral research, microbiology research in general. Like this, I genuinely love doing Coffee with a Scientist to provide a space so that people have an opportunity to talk and ask questions of other types of scientists that either for whatever reason they don't have the time, maybe this isn't their gig, maybe they just don't have the know-how, that they don't stream on Twitch, but they still feel like they have good knowledge to provide to the public, and we want to be able to give you a space to ask them questions. Like, that's why Belint does these collabs.
And you had Nerduino on recently too, so one of friendos of the community.
Yeah. And then I in April, I'm hoping to have a gal on who's a herpetologist, so we can talk about some amphibians.
Nice.
Maybe a mantle geochemist. We can learn about all the voodoo they do to learn about the inside of the earth. Because, like, we've learned now, like, Belint, how do we know what's inside the earth? Like, we can't see. All we can do is measure changes in seismic velocity. And every once in a while we get lucky and these volcanoes bring up little bits.
The football.
And that's, in a little football. And that's all we've got.
Because like you were saying, like when you do start digging, stuff just melts away. And it's kind of humbling that that's what happens. You're like, oh, geez, that's...
No, our drills just melt.
It's not what I was expecting as a potential pitfall. It's like the drill's melting. It is something to think about, and it's super cool. And I'm tonight just like highlighting the intersection of like volcanology, geology, biology with like these samples too. And I don't think that we would have had that if we didn't have these kinds of crossovers and talking about these connections. And it's something that some sciences are very insular, and so having these, like the Coffee with a Scientist that you're doing, I think could yield to really exciting... Tommy Two-Tap, thank you for the follow. Like, really exciting overlap as well.
I think, like, people too often, like, think about science as, like, oh, you're a geologist, oh, you're a biologist, oh, you're a geneticist, oh, you're a physicist. But there's all these, like, cool overlaps. Like, I do geophysics and geochemistry, and I'm a volcano scientist, and I do igneous petrology, which is figuring out how igneous rocks form. I wear lots of different hats, and I'm sure you do too.
Sometimes it feels like there's too many we're balancing.
Yeah. So,
Um,
but I am gonna go get dinner soon. I'm gonna go get supper. I will say that if you would like to follow me, I am Volcano Doc pretty much everywhere. I stream on Sundays and many Saturdays that are on the calendar. I will definitely enjoy this soup corn relish. I am very much looking forward to it. I have a Twitter, I have a TikTok, I have an Instagram. And depending on whether or not I get a job, a academic position this year, I may or may not be going for partner. Who knows?
Independent of that, y'all, I
Actually.
think she should be partner. I'm just throwing it out there. This is like a trained, real life volcano scientist spending her time on Twitch educating people, and that is really laudable. Like, she has the expertise. She's not just like loosey goosey, like, I saw a movie and now I'm going to talk about it. Like, she did the work, and she's really
I will
good at
tell
it.
you when I don't know, as I have on stream. Coffee Rocks, I have a schedule. I run on geologic time, and that's the problem. Is that my schedule is kind of depending on the sun and my family and my research and the geology and sometimes you just can't plan for volcanic eruptions, and that's why you have to follow me and have your notifications on.
But usually Sunday evenings corn relish for our Eastern time.
Yeah, usually around afternoon, 4-ish Eastern. Or whoa, Pacific, 4-ish Pacific. Oh my goodness. Whoa. I need to leave. I need to eat food because I have to work tomorrow morning. I have to go. Actually, while I have people in chat, I have to go, and I'm going to shamelessly plug. Make sure that you clean up your dog's poop. Please, make sure. Okay, poop pays my bills right now. When you don't pick up, your dog's poop is literally raw sewage. It contains lots of bacteria, like Giardia and E. coli. And when you don't pick it up and it rains or it snows and that water melts, that means that E. coli and Giardia and lots of gross fecal coliform bacteria, doesn't that sound lovely, gets into your water. Right? So, and yes, you don't want to walk in it, but pick up your dog's poop. Okay? Pick it up. Use biodegradable bags. That way there's not lots of plastic in the landfills, but pick it up. Even in your backyard. I know it seems like it doesn't make a difference, but all that bacteria goes somewhere. So pick it up even in your backyard. Sorry. Poop pays my bills right now.
Y'all heard it here first. Pick up your dog's poo. Or yours as well. I don't judge. You don't have to use a toilet.
Yeah. Make sure you pick up after yourself. Just pick up the poop. Pick up the poop.
Well, Volcano Doc, thank you again so much for your time tonight, for coming on, for the sample, for everything you do, for the TwitchCon science panel. Just, you do a ton, and really, for sharing your story, everything. Thank you so much.
Thank you for having me, and for the panel, and for everything, and providing this amazing space, and for you and Lita and everybody that was on. Science Twitch wouldn't be what it is if it wasn't for you and people like you, Danny, Hoodles, Nerduino, Rocket Sage, Astro, Danny, everybody under the sun. I am really hoping that Science Twitch can just be an amazing resource for people who might not have access to people like us otherwise.
I think we're on the precipice of something like that happening. I really do. Well, Doc, thank you again. Enjoy your dinner, and we'll see you real soon.
Farewell, fearless leader.
Good night, Volcano Doc.
Good night.